in disaster management in National Institute for Disaster Management, a eminent institution which works very closely with all the policy makers at the highest level. He's a resilience and sustainability strategist, lot of experience. He works at the at the intersection of environment and disasters. He has several publications to his credit. And almost on all aspects of environment, climate change, we consult him. We depend upon his expertise and his erudition. So I will ask Professor Anil Gupta to say a few words. I also would like to briefly introduce all the great panelists that we have with us today. We have Professor Astiani from Iran speaking. I know Professor Astiani for a long time. He is an eminent earthquake engineer from Iran. He has worked on these issues and on the earthquake issues for a long time. And we are so honored to have him. He's joining us remotely. We also have from the left, I will introduce Dr. Rupam Shukla. She's assistant professor IIT Roorkee. And Dr. Shukla has, I think she has a PhD from Terry School of Advanced Sciences. She works again on social vulnerability assessment, differentiated perception, risk attitudes to hazards, on socio-ecological systems and disaster risk reduction. I will be brief with my introduction, so please forgive me. All of them have very distinguished academic and educational records and distinguished track record of teaching. Dr. Upasana Sharma, Associate Professor on my left side. Dr. Upasana Sharma, Associate Professor IIT Delhi. Her research interests lie in the intersection of adaptation to climate change and risk reduction related to natural hazards and variability. Her work relates to conceptualizing and measuring vulnerability and adaptive capacity to climate risks. We have also Professor Janki Andharia, a long time colleague, comrade, she 25 years of working together. Professor Janki Andharia is currently the Dean of the School of Disaster Studies, Tata Institute of Social Sciences. She has over 37 years of experience in the field of community organization, social development. She's an eminent professor. She is an eminent scholar in the field of disaster management. We also have Dr. Nisha Mediratta. She is leading the climate change. She's the advisor and head of climate change program, Splice Division, and Women in Science program of the Department of Science and Technology. She is spearheading 2 national missions on climate change under National Action Plan of Climate Change. So we have great panelists. So now I will invite Professor Anil Gupta to share his thoughts. And then after that, I think I will invite Professor Astiani to speak. Thank you.
I got a chance to interact with you, sir, earlier.
Yeah.
Maybe Dr.
Yeah, thank you, Chair. In fact, Chairperson Dr. Krishna Vatsa has introduced all the panelists, but it is also a duty to briefly introduce the Chairperson. Ideally, he should have been introduced in the beginning. Dr. Krishna Vatsa is honorable member of National Disaster Management Authority of Government of India. But more to that, in person, he is an internationally known expert on disaster risk management. Has started his journey as a civil servant of Government of India, has been Relief Commissioner of Government of Maharashtra, and handled the Latur earthquake, the entire rehabilitation and recovery program. And that is what the beginning of his journey directly into the domain of disaster management. And then he has a long the list of contributions to disaster management internationally. His contribution more towards recovery side and crisis prevention and recovery, working with the UNDP, BCPR, and several other domains relating with disaster risk management and the post-disaster issues is very important and to refer here. And currently he is guiding India's disaster management efforts and journey, being a part of the Disaster Management Authority, which is headed by the Honorable Prime Minister. Now, thank you, Chair, for some points from my side. I am not using any PowerPoint, but a few thoughts I have here to share. The very important that when we are talking about the climate sensitive disaster risk management or climate smart disaster risk management, we find that significant pilots were there over past 15 years or so in promoting climate change or climate resilience aspects for the benefits of disaster management. But now what is important that how do we scale up? And how do we really mainstream into all the spheres of development, because India being a vast country and a diverse geography. So that is the biggest challenge. And just to share with the audience, some may be already aware that Government of India has recently submitted the first ever adaptation communication to the UNFCCC. NDMA has been there at the helm of affair, and IIT Delhi has also supported us, and that is the first time that DRR has been discussed in a very strategic way. However, we had a number of lessons. I will be just taking few minutes to list those out. The journey of thinking of disaster risk management in a strategic way it started with a thought process for DRR that goes back to 2006-7, when we had a initiative of UNDP for the JEF project. There we had covered 3 states, and we did a lot of consultations with a number of partners. In fact, Terry was also a partner. MOEFCC was steering, and I was also, in fact, in that. Then we could also see that how the climate change issues can be considered in district level planning process, looking at disaster risk and disaster risk management. And I would also refer to the first ever such kind of model that has been developed, that is called as Gorakhpur model, that was published in 2014 jointly with NDMA. And that is now being used not only various districts in our country, but also various other neighboring countries where the district kind of approach is there. Then the issues of the urban systems, when it came, then we started also discussing about the peri-urban systems. And with UNICEF also, we had a couple of such initiatives. And in fact, we could work out that how differential vulnerability need to be assessed, like the men and women, they are differently vulnerable. Then children particularly, and within children, the urban poor children, and within our urban poor children, the girl child, how their education, how their health, how their water and sanitation, how their food and nutrition, these dimensions are also being affected. So that was also a part of journey, and we published a number of papers with UNICEF also. Then with a number of pilots, the issues came that how do we map the pathways and tools, and that was a series of efforts, and with partners we did these kind of interventions also. We could come out with some significant reports on loss and damage assessment, and we carried out a mapping study of 25 years, which has been released a few months back. Dr. Krishna Vatsa only led the discussion in that follow-up in the premises of new campus of an IDM. Then just to share that with Ministry of Environment, Forest and Climate Change, a knowledge compendium has been developed, and now we are going to publish it jointly with Springer. on adaptation for DRR. So that is the first ever such kind of a, almost 50 authors have contributed to that on various aspects. Then the another dimension came in this line is on promoting nature-based solutions. And jointly with the United Nations Environment Program, UNCCD, and many others, in fact, UNCCD COP that was hosted in India in 2019, the first ever event on this aspect, that how do we look at nature-based solutions to promote drought and other disaster resilience. So first ever compendium has been recently published in 2020 by India, compiling the case studies across Asia Pacific so that we can focus the inherent knowledge and case studies in this line. Then two more points. One is that recently we have come up with a very important dimension that is close to the thought process that always the chairperson always refers to, that how do we improve our the relief and recovery process. So how do we climate proof our recovery process, post disaster recovery process? So a manual has been just released few days back, and I think it has been uploaded on the website of an IDM also yesterday. So that is a very important thing. And the last point as a feedback or message from my side, that we have a number of initiatives and as pilots, as case studies. Now, how do we look at some kind of a mapping of these initiatives and the lessons of those pilots, and to see that how do we upscale, how do we mainstream into all the domains associated with disaster management, so that we can really see the ground change. So now we have policy interventions. How do we link it with bringing change on the ground? So thank you very much, Chair, for providing me this opportunity to flag some of the issues. Thank you very much, and looking forward to listening to the expert panelists. Thank you.
I will now invite Professor Ashtiani. I think he's connected to us from Iran. So Professor Ashtiani, if you are there, if you can hear us, please join and just introduce your area of discussion. I request you to speak for 10 minutes, if it's okay. Thank you.
Good morning from Tehran. And do you hear me?
Yes. Yes.
Okay, if you can, I have sent my slide to Mrs. Sangeeta. If she can share it, I can go through the slide, or if it's not possible, I can just give a talk over the just verbally. Can you share my slides, or?
So, like, you have to share it at your portal itself.
I know, but since I could somehow I cannot get connected to my computer, I'm getting connected to my mobile. Therefore, I will just explain by words, okay?
Okay, that's fine.
Okay, we are living in an Asia, a very complex continent with a lot of complex problems. And especially we are facing in Asia with the rapid growth of urban development and rapid economic growth. And this growth also faces with the high level of hazards and vulnerability and risk. And as you know, that Asian cities, especially the big cities in Asia, are among the highest risk level in the world. There are many reasons for it. One is that most of decision makers are not risk informed. People are not risk informed. And also this growth and this population and economic growth and urban growth are not risk-based, means the development is not compatible with the level of the risk and hazard that is exposed in the cities. At the same time, when we have this development, People are becoming more aware and they are demanding for more safety, safe homes, safe housing, safe shelters, safe schools, safe hospitals. And at the same time, there is a question, do we have enough knowledge and know-how to make our city development a sustainable development and resilience urban development? The answer is that yes, there is enough know-how in the world and in Asia to have this development process in a safe and resilience and sustainable. Why, despite this knowledge, why we are not approaching that direction? Because we do not have a comprehensive look and systematic thinking for the urban development. We have a lack of systematic approach to disaster risk reduction and urban resiliency from the point of prevention, preparedness, response, recovery, response, and post-disaster actions. We have a lack of urban governance system and a poor communication between various stakeholders that can contribute to the safety and resiliency of our urban area. And at the same time, we have a lack of integrated look at the nexus of energy, water, climate, and food and everything. Okay, these are the challenges, and these challenges can be pinpointed to different points. For example, look at housing in Asia, which is a biggest challenge right now. We will see this issue, which I have mentioned, even on a single component of our urban area, which is a housing. We have lots of illegal housing, unsafe settlement, which affects our urban resiliency. One of the biggest challenges in our urban area, I'm just giving an example, is a safe and affordable housing. This is a big challenge in most of the urban area in Asia, especially in East Asia. Having an urban resilience, it involves many items, which I have shown it in my slides, but I'm just giving verbally. So many components would contribute in order to have an urban resilience, from governance, from social, from law, from knowledge, from the economy, from culture, many things. And when we look at the urban growth and urban development, each of the players look at their own angle. For example, the people in the governance, they look at it in an indifferent way. The people in economic, they just want economic growth. They don't look at the other social and cultural and find other things. Or those, for example, with engineering, they just want to build without knowing what kind of stress they put on the city from the energy, from water, from climate, and all these things. Therefore, in other words, each of the players in the urban development, they look at the problem in their own way. And if we ask for the urban resiliency or solution of urban safety, each of them also, they look at their own way and provide solutions. In order to make a cross-section to the problem and try to solve that problem. And when we look at the end result, we are not achieving, even though we are working hard, but we are not achieving an urban, sustainable urban resiliency. Making my talk short, if you want to have urban resilience, you have to look at economic point of view, political point of view, legal system, cultural, and technical and engineering. These have to work in an integrated and in a systematic approach in order to achieve this one. The urban communities, they should work with the rural community because their problems are interrelated. The scientists, they should work with engineering and development. They have to come to a one agenda. The financial market, the insurance, the banks, they all also same thing. And also legislative, they should work together in order to, for first, we have to first create a synergy or integration among similar players. Then we have to create synergy among all of the main stakeholders toward one objective of safe and resilient cities. Then we have to look at bring them to a one system and in the nexus in order to reach our objectives. What IIASA, since we are dealing with IIASA, therefore, in short, if we want to have an urban resilience, we need to look at urban in a system as a system, and with a system thinking, and this system thinking can be considered by all the stakeholders, from the governance, from official policymaker to the people. Having said that, we have a IIASA, which you all member of it, that has the knowledge of system analysis and system thinking and system modeling. And in Asia, we have a problem that we need to apply this system modeling and system thinking into our urban development, as one example, into housing, in many things. Therefore, Iran National Science Foundation, and we are proposing, and we're trying to take this flag with the help of our colleague in India and Korea and Japan and other things, and China, to launch a IIASA Asian NMO working group to deal with application of a system approach toward sustainable urban and urban resilience. There is a need, there is a knowledge, and this need and knowledge can be integrated together. And I would like to invite my colleagues, NMOs from India, from China, from Japan, from Korea, from Jordan, from our other countries, to hand together to form this working group within the IIASA. I have discussed with my good old friend Gansen, which he is in the also in the meeting, to develop this working group toward establishing a strategic initiatives program in IIASA, and that can be a platform that can continue what we are discussing in the program, in the conference in India today, in October in Iran, in the past in China and Japan and other, that from this conference, we would want to have a result, something that we can say, okay, we just had a conference, we meet together, but we are carrying an initiatives. Therefore, again, my proposal is to form a IIASA Asian NMO. Other can join, there is no limitation. But Asian NMO to work toward using the system modeling and system thinking for developing an agenda and program and direction policy for urban resilience, sustainable urban resilience in Asia. Thank you so much.
Thank you. Thank you, Professor Astiani. That was very, very profound. I think you have made a very strong case for a systems approach to urban resilience. It's an area with multiple jurisdiction, and we often find how agencies work at cross purposes, and it's very, very important to have sustained communication among the agencies to achieve optimal results in the area of planning, governance, risk reduction. So all the suggestions that have come from you and this initiative that you are thinking of, I think very, very laudable, and I'm sure there would be a lot of positive response to this. Thank you very much. I now
Again, I would like to thank, I would like to thank Mrs. Sangita and all the IIASA for the organization of this conference. And I'm sorry I'm not in person. I would love to be in person in New Delhi. And I invite all of you to attend the October conference in Iran.
Yeah. So we definitely would like you to come to Delhi more often. Professor Stiani, you are a doyen of earthquake engineering. We know of your huge amount of work in Iran and elsewhere in the world. You are most welcome, and we sincerely hope you join us next time in Delhi and in many other places in India. You are a true friend and a great scholar. We so much respect you. Thank you.
Thank you so much.
Thank you. I invite now Dr. Nisha Mehendiratta. She's from the Department of Science and Technology, and she will, I think you about 6, 7, 8 minutes.
Hello? Yeah.
Yes, go ahead.
So by the time he loads the presentation, I think because there's a shortage of time,
Sure.
I'll just start that way. So first of all, I would like to convey my greetings to Chair Dr. Krishna Vatsaji, member NDMA, Dr. Anil Gupta, great friend from NIDM, panelists who are there on the board, and also the experts who have joined us virtually, all the participants here. I would like to thank TIFAC for organizing this very special event, and actually it is need of the hour. So in fact, it is on discussing the strategies for climate resilient DRR. I just thought of giving an overview about the initiatives which Government of India has taken through the various national missions on climate change, which really encompass many sectors, and DRR is one of the most important sector in that. So that's why the topic I chose was climate change perspective and strategies under the climate change mission. So as already in the sixth report, it's quite evident. 1 minute, please, the screen, I want to put it down. Yeah, that ecosystem-based adaptation approach has to be adopted. That is the thing which came out in the latest report. And there are many more things, many more facets in which they are trying to focus on sustainable lifestyle. This should come at the end. Yeah. And even this year's COP, which just recently we received the details from MOEF, talks about that particular thing, life. LIFE is the thing or the subject area which has been chosen. And we are going to have many side events in the conference of parties, and DRR is going to be one of the main component in that. So in IPCC, the main aspect covered is ecosystem-based adaptation can reduce climate risk that many people already face, which is in terms of droughts, extreme heat, floods, fires, and many more things. As already mentioned by Chairman Sir during his session, his remarks that many parts of the country, let it be northern part or the eastern part or central part, there are many kind of disasters which are faced by our country, India, and there is a need to look into the proper strategic measures And there are many agencies which are looking after that. But this is the need of the hour, that holistically whole world look into that, and we need to look into the macro as well as micro level strategies. So this is a very well-known pointer is there. Yeah, the depiction given in the report, I am just skipping that, but only it is talking about the climate change causes impacts and risk. It is well-known fact. Anthropogenic issues are quite prominent in leading to the climate change ill effects for the human being. There is a need to go for urgent and timely action to limit the global warming. So the second one, which I am trying to show, it's not going down. There is no pointer as well. Next slide. Yeah, so actually next slide I was trying to show, it's not coming. Yeah, I just wanted to give an overall perspective that we are talking about 1.5 degree rise. Just 1 minute, please. Tell me how it go down. No, it's okay. It's okay now. Yeah. So broadly, I mean, nahi, abhi theek hai, it's working now. So mine is the first one. No, so little glitches are expected. So like quickly, I'm just focusing on drought and rise in sea level because I have to limit to my time also. So here you can see very well if there is a rise of 1.5 degrees centigrade, or if it is risen to 2 degree, what kind of devastating effect it may have on drought. And if there is a rise in sea level, what kind of severe adverse impact it's going to have on people. So this thing is showing pointer that million of people affected, 410 million people are likely to be affected if drought continues to be like that. Similarly, if there is a rise in sea level, 49 million people would be affected. So very, very strange figure, I must say. So this again I'm skipping, which talks about certain countries, because I heard the friend from Iran, he was mentioning about many important aspects. So I am also eager to mention about some of the country which I have picked up from one of the document only, that if, I mean, in least developed country, small island developing states and Africa will be the most affected, who are actually the least CO2 emitters. That is one point I want to highlight here. There are many countries who are not contributing to the emission, to the global warming, but they are going to have burnt of climate change tremendously. So that is what we have to look into and what we can offer to them. So there is a need to find out new ways to cope and adapt to climate change. And all like we know that adaptation and mitigation and climate resilience, that is what we need to know. Now, what kind of process need to be taken up? So I am talking about only one thing right now, that we need to really assess the impacts, vulnerability and risk. Earlier we were talking about vulnerability. Now the risk assessment is also very, very important. I will not go into details of all that. Now coming to the Government of India's initiative. Government of India launched NAPCC, National Action Plan on Climate Change, in the year 2008 and 9. Now we have done many things in terms of adaptation and mitigation both. 8 missions were launched, and then 2 new more have also been added. One is for coastal and health. And DST is looking after 2 major missions. One is NMC for sustainable Himalayan ecosystem. Second one is to develop strategic knowledge to understand the impact of climate change on all the sectors. And DRR is one of the important like aspect in that, which NIDM is bringing the human capacity building aspect in that. And Professor Vinod Sharma ji is also here. I am thankful for his venture that he's providing many modules through IIPA on this particular subject. Now, as I said, DST is implementing 2 out of these 8 missions. The main focus is to build national S&T capacities in the area of climate change and research and adaptation to climate change. These are the broad thematic things. I am skipping it. Only I want you to just spend few seconds on this slide, because there are when DST started working on these 2 missions, we were totally like we started from the scratch rather, unlike other missions who are concentrated on their own mandate like energy, water, agriculture, environment. They have their own big ministries, but DST is a R&D body. So at that time we thought we should start the networking among the institutions who are working in the similar field of climate change, and also we should strengthen them. Then we started creating center of excellence. So I'm very happy to state that at present we have around 12 major center of excellence which are concentrated or located around the national institutions having tremendous R&D capacity, which are IITs, ICRISAT, IASC. You can see the list, I will not speak. But here, you can see the range which we are covering is starting from climate model development to coastal vulnerability, urban flood modeling, agriculture adaptation, and many more things are there, which straight away goes to the strategies for DRR. Similarly, we have given major functioning through major R&D projects again to the 23 institutions of the country, and again it's wide range in which DRR is a very important segment. You can see sea level rise, storm surges, and even for glaciers. Glaciers also, the glacier melt, flooding, even cloud burst, many things are happening. Vadia Institute is working in those issues with us. So few network program also we have started. Each network is comprising of several R&D projects, and there are a team of scientists working in each of the thing. And here also the thematic areas are climate modeling, human health. That is again a very important segment, coastal vulnerability, aerosols, urban climate. I just heard, like sir was also saying, that in urban areas also the DRR, we need to look into it separately, I believe. So we have initiated a network on urban climate as well. So we can provide more details later on, and we are very happy if like we get the joining hands from the organization. Sir, please let me know the time because there are many more.
We can finish this.
Yeah. So I'll just skip many things. I'll just come to the end. So likewise, another important thing is dedicated state climate change centers, which DST has established. Right now, 28 states are covered, which is one of its own kind. I don't think in any other country these kind of centers are set up at the state level. And these centers together have worked together to generate vulnerability assessment. And we have already done ranking of 29 states. So this can you can get a feel of it that all the states are vulnerable in India. That is one of the outcome. And there are many more things. Top 8 most vulnerable states are also identified, which are Jharkhand, Mizoram, Odisha, Chhattisgarh, Assam, Bihar, Arunachal. And we have brought out a document of that. IASC Bangalore, IIT Mandi, and IIT Guwahati. They worked with us in such an important, unique work. And the most thing is, most vulnerable are the most poorer. So I want to just finish by this statement. So the task given to the scientific community is look into DRR and how we can provide a healthy, sustainable lifestyle and life to to the citizen of our country. So I just want to end from the last quote. There are many more things I thought of showing, but anyhow, maybe at some other time. So this is the vision of DST through our these two missions. Now we want to focus on urban climate, extreme events, glaciology, climate modeling, Himalayan ecosystem, and impact of climate change on various sources. We are in the process of developing the concept and initiating the programs. And as I said, that we will be very happy if all of you give the idea to develop these programs. So I would like to end here with a statement that the greatest threat to our planet is the belief that someone else will save it. So it's only we who have to save it. We should not look around. And we have the potential, capability. It's only the time to join hands, pool up our resources, and show the results. Thank you very much.
Thank you. Thank you very much. And so good to know there are so many initiatives being conducted, and it was really good to see how the states are being ranked according to the vulnerability. These are these hold very important policy lessons. So I think it requires a more extended discussion how the states are being ranked, and some of these states need to be supported accordingly. Very, very important for our policy making.
So, sir,
Thank
I'll
you.
take
And
leave
yes,
then.
yes,
It was
thank you
wonderful
very much.
meeting
And
you.
we will interact
Sure,
further.
sir.
Okay, thank you.
Thank you, everyone.
Yeah, thank you.
I have to proceed to another
Thank you.
meeting.
Thank you. I now invite Dr. Rupam Shukla, and she will be speaking on the role of in local institutions and social capital in building climate resilient disaster risk reduction. This is again a very, very important area. Um, as we know, the local institutions are playing a greater role now. All the Panchayati Raj institutions, urban municipal governments, their role in disaster management is slowly increasing. And with I know that at the highest level in the government, there is a greater recognition of the role that they can play. Also, I think there is also a greater recognition of the role of social capital in disaster management, how the social networks have come together, how they are using some new tools of social media, of networking, of connections to improve the practice of disaster risk reduction. In recent disasters, we have seen the role of social capital. So I think this is a very relevant area, and I now invite Dr. Rupam Shukla to speak on this. Thank you.
Yeah, thank you very much, Chair. And it's my heart. I want to express my heartfelt gratitude to all the esteemed panelists who are sitting here and the speaker. It's an honor for me to share this, this stage with you all. And yeah, so I would like already introduce by the chair that I'll be talking about the role of local institutions and social capital in building climate resilient DRR. And a brief introduction about myself. I am Rupam Shukla. I am an assistant professor at the Center of Excellence in Disaster Mitigation and Management at IIT Roorkee. Recently joined IIT Roorkee, and prior to this, I was a postdoc in Potsdam Institute of Climate Impact Research, Germany. So today, a lot has been said. The stage has already been set with the discussion and the points that have come from the chair, from two of the speakers who have addressed the gathering before me. I will start by sharing some of my thoughts that I've gained through my research and through empirical evidences that we have worked on in different scales in different regions of India. So I'll start by giving this global perspective. This is a study that was published recently in One Earth, where we compared how equity is addressed in risk response. As in, equity means that if, as Professor Nisha Mendilata, she just said that poor are recognized and they are more vulnerable. The concept of differential vulnerability was also introduced by Professor Anil. So how these vulnerable groups, so we identified 8 vulnerable groups, and how these 8 vulnerable groups are accounted in risk response across the globe. We looked at different regions. So as you can see, one of the generic finding that I can conclude from here is that global south is integrating more vulnerable categories, which are women, low income, or disabled. But when we look it across different sectors, and when we expand it on different different timeline, we see that there are certain gaps. There are certain evident gaps. First is that the disabled and the migrants, I don't know if one can see, yeah, you can see the mouse here. So the disabled and the migrants are least accounted for in these global risk response mechanisms that are there. Moving forward, it is established, there's science coming in, there's evidence coming in, there's news policies, reports coming in now that I'm speaking, that disaster risk is increasing. It is induced by climate change, anthropogenic climate change. So this all is increasing. But it's important to realize and reiterate that these risks are uneven. They're not spread equally across different sectors, regions, and across communities. So a region incorporates, different sectors such as agriculture, water. This was also being spoken in the, panel, the first session that we had. So what I show here on the right is one of the study that we undertook on understanding how different agroecological zones in India and the districts within these agroecological zones are vulnerable to climate risk. And we identified that there is some bit of spatial distribution. And these red zones that you see are identified as highly vulnerable. Further, we were motivated, to see that, okay, if these red zones are showing high, are all communities living in these red zones equally vulnerable or not? And that is when we introduced the concept, using the concept of differentiated vulnerability. We looked at farming households in some of the identified regions in these red hotspot that I showed on the image before. And then we looked at farming household diversity. We looked at farmers as at the core who are making decisions of responding to risk or doing some kind of adaptation to climate and disaster risk. And then there's two other sets that they have their forest and livestock. And this was particularly done in the mountain system. Therefore, forest and livestock were also considered equally important. And then they have a subsystem of the crops. There are a wide range of factors that influence the farmer household diversity. These are internal factors that emanate from the household characteristics in terms of the assets that the household has: natural, social, human, physical, and financial assets, and the individual characteristics or the individual beliefs that the farmers have in terms of their orientation or what they want or their aim or their belief towards farming. Then there are external factors such as market, their extension services, presence and absence of, communication and agriculture training officers, and some policies that enable certain actions that the farmers are taking, or also sometimes constrain some actions that the farmers want to take. So we collected data on this. This was done on primary survey. And then we wanted to look at how differential vulnerability leads to differential adaptation of these farming communities. So what I'll just quickly conclude from here is that there are different types of households. So we use some statistical methods to classify these households into different categories. We identified 5 categories of farmers, and these 5 different types differ in terms of the resources that the household has, in terms of the orientation that the farming household has towards farming. These were the 2 main axis along which the differentiation or the categorization was made, and which also doesn't come very surprising that because these farmers vary in terms of the endowments, the resources, the capital that they have, and the orientation they have towards farming, the kind of response that they take towards any kind of risk, climate or disaster risk, is differing across a continuum. So we could identify this continuum, as you can see here in the brown shade. So some of the farmers are stepping out of agriculture. There is a subset of farmer who is and they have the capacity to step out. They're moving forward. They're moving one step, let's say, ahead of what they're doing right now, and they're integrating or they're getting into some new kind of business, some beekeeping. But on the other end of the spectrum, you see that there are different types of farmer type 5, which have low resource endowed and mostly are farm laborers. They're dropping out of that kind of a profession and moving and migrating towards another occupation. So this, as this was also, said by the professor from Iran, that it's very important that we take this kind of systematic and interactive look of how a community that we think might be equally vulnerable, but it's not the same. Even within a community that is living within a geographical region, but the assets and the livelihoods make a lot of differences. And then moving on to social capital a little bit. So we captured social capital using how the communities or the members have access to the local institutions. Are they a part of some of these SDGs group, or they can access their neighbors, they can have funding from, or they can have some kind of support from their neighbors. and how that is being impacted by the climate impacts or the climate risks that the farmers are perceiving. So one could see that there is some kind of difference in these five. So on the on the y-axis, what you see are different types of farmers, and the red ones are where the differences are significant. So the type 4 and the type 5, the low endowed farmers say and perceive that there are major impacts that are being felt on the social impact, social capital. Moving forward, this was also said before, and the stage is already set, like I said, that there are a lot of gaps, that there are a huge number of policies. The government has the intent and they're trying to support the farmers. But why are things, why is that there is an implementation phase, implementation gap, or things are not really turning out on ground? We did a review of 10 policies which are based on supporting farmers for adaptation. And then we also compared it with the literature that is coming on adaptation. So we see that there's a difference. So on the left is the keywords that are coming from the policies. On the right, there are keywords that are coming from the literature. So one of the biggest difference that one sees is that a lot of our policies are oriented towards agriculture systems, but not so much towards the farmer and their identity. So these are the things that one could take into account. And now one of the further studies that now we are involved at IIT is that we're looking at how social capital and disaster recovery is related. We're collecting data from different sites in Uttarakhand. And we have identified a set of factors that are, enabling or having some impact on self-reported recovery. And the initial results of the studies in progress, and the initial results show that social capital, or people or the communities or the individuals who have access to better social capital, are reporting better self-recovery. So some of the conclusions that I can draw from my learnings is that it's important that we view disasters from a social equity perspective, so that because these risks are uneven, these impacts are uneven, it's important that we get into the perspective of equity when we're trying to formulate some responses and policies, and understand that disaster risk is not only uniquely depend on the hazard processes, but it's also much more in some ways determined by the vulnerabilities, which differ in time and spatially as well. And then again, linking it to the inequalities that are existing. And therefore, we need to support the local institutions and local bodies, so that these kind of heterogeneities can be accounted in the policy making. I would conclude with showing one of the recent paper that I'm very happy and pleased to share, that we published in Nature. I'm one of the co-authors, and the study highlights that there is a need of integrated approach for disaster risk response. We have looked into landslides and how urban informalities are cutting across landslides, and the study also identifies the need of dynamic vulnerability and risk assessment, and underscores that there's no such thing as a natural disaster. So integrating social perspectives is equally or much more important for DRR. Thank you.
Thank you. I mean, this is an area that has been studied in great detail, and I mean, we know that certain segments of farmers are more vulnerable than others, particularly the small and marginal farmers. And one of the policy challenges is to how to provide them greater access to resources, how to provide them greater access to information. And this is a large part of the agrarian distress could very well be explained in terms of the vulnerability of the small and marginal farmers. And clearly, what we have seen also, I have dealt with this issue, that wherever the level of social capital is high, wherever there is greater social networking, the distress is much, much lower. And wherever the social structure is more fragmented, more divided, and people are more marginalized, the level of distress has gone up. So this is an ongoing debate within the DRR discourse, how to provide more and more resources, not just in terms of the financial resources, but also in terms of knowledge and technology, to the people who are actually on the margin, and this definitely plays a very important role in reducing vulnerability. So thank you very much for this presentation. Now I invite Professor Upasana Sarma, and she will be speaking on the improving response to cyclone warnings, lessons from empirical work in the east coast of India. As a result of the climate change, we are seeing the rise in the temperature of Arabian Sea, and we see more and more cyclones happening on the western coast. So I think it is also time to know more about improving response to cyclone warnings on the western coast, not just on the eastern coast.
That's okay. Hello, everybody. So I'll quickly move into the topic. So basically, these are some insights, and this is based on old work. This is not very new. There are elements. So we've studied cyclone warning response processes on the East Coast, and as Mr. Vats has clearly, correctly mentioned that earlier East Coast was more vulnerable to cyclones compared to the West Coast, where you used to have less incidences. But that's changing, and it's equally important to extend this work because the cultural and social contexts in both the coastal areas are different. However, I think there are certain common insights that could be equally applicable for improving public response to cyclone warnings, even on the West Coast. We had studied cyclone warning response in the context of some cyclones on the Tamil Nadu and Andhra Pradesh coast in the year 2006 and 7, and then more recently in 2018 in the Odisha coast. So it's a little bit of a set of insights that we got across these different studies that we did. So hazard early warnings to public are an important part of disaster management because it's the hazard warning which is very often the first sort of stimulant to creating, perception about risk. So there is a risk, one needs to respond, warning systems extremely important, right? But the important question is, do warnings lead to desired action on part of the public? And the evidence on that is pretty, I would say, varied and ambiguous. In certain instances it does, but in many instances it does not. Either there is over response or there is not adequate response. For example, in terms of evacuation, which can lead to greater risk to human life and also greater risk to personnel who are trying to rescue and intervene right in the middle of a disaster occurring, right? So very quickly, warning response process typically involves obviously the communication of warning, and then once the warning is communicated, perception and evaluation of that warning information by the recipients of that warning to arrive at a decision and then actually take action. One schematic by Milletti and Sorensen, a classic in the field of disaster management. One would hear the warning, process it, sort of confirm it, and then understand or personalize it and respond accordingly. And there are a host of receiver and sender factors. Sender factors means the attributes of the warning system itself and the message itself. And the receiver factors essentially refers to the context in which that target recipient of the warning is located. So we actually sort of spelt it out in detail what these warning or sender characteristics are and what are these receiver characteristics. So message attributes, source attributes, channel attributes, frequency attributes, timing of warning, language of warning, all of these have an impact on how your target recipient is going to respond to warning or not. And of course, that is not the only thing. What kind of environmental attributes are they observing? Cues, social or physical, proximity to the hazards, likely location, what are their networks, what resources they have, what are their levels of education, their psychological attributes, like what is their knowledge about the hazard itself, the cognition, about different kinds of risks, like fear of looting. I don't want to leave because my house may get looted in my absence, and perceived risk and self-efficacy and experience. Experience is hazard experience. Is past hazard experience is an extremely important component about which I'm going to talk, and physiological attributes. So those are the general demographic factors typically. So the way so I'm not going to go into the details of the methodology because these are published papers. You can read all of that. I can easily share that with you. What I quickly want to move to is what do the insights mean for the practice of disaster management, particularly from the point of view of improving warning response. So 3 phases. And most of our insights are really for the pre-disaster, which is the preparedness phase, and during the disaster, which is the response phase. And we've identified actions that can be taken at 3 levels. At the strategic management, of course, these are not watertight levels that at the top level, there is only strategic management, tactical and operational doesn't happen. But by and large, this is how things move. Just to give you a general schematic of system for cyclone warning dissemination in the country. So at the strategic top level, policy level is the NDMA, and there is IMD, which is actually doing the generation of the forecast, the warnings, and so on. There are area cyclone warning centers, and at the state level, you have the state chief secretary, and then at the district level, and till the last mile. I don't want to spend too much time on it, as most of you are well aware of this. I quickly want to take you through what were the main findings. We did initial exploratory qualitative studies in the beginning, but later on we did a full-fledged survey using a structured questionnaire, and we analyzed our data using statistical techniques. But again, as I said, all of that can be seen in the published papers. But what were the main findings? Quickly take you through that, and then we come to the what does it mean for improving the practice of disaster management. So very important was that, so evacuation was a dependent variable. Did people evacuate when the warning reached them to evacuate? Yeah. So so message contents matter a lot. So what are the contents of the message, particularly if there is information on what is the protective action you need to take, and what are the locations which are really at risk. So extremely important that these should be there in the message, then people respond more adequately. Clarity obviously is important in terms of avoiding technical jargon. Certain English words may not be understood in areas which are rural, and channels of warning, public announcement systems, which have become pretty old, but in certain places they are still used, and sometimes they make the warning a little bit unclear. Uncertainty in warning. So our general perception is we should not be conveying uncertainty in the warning because it will not lead to response. Counterintuitively, we find that actually the receiver prefers. Actually, the receiver is very savvy because they've been in the area, they know cyclones, they know environmental phenomena are not absolutely, they can't be predicted with absolute certainty. So conveying the message as a certain message and that thing not happening actually leads to greater disbelief, and conveying uncertainty is leading to greater belief in the warning, was one of our findings. Type of channel, we found that media channels were not very effective in making evacuations happen. Of course, they increase the awareness a lot, but people wait and watch. And it's the local village official which is most effective in ensuring evacuation. Then wrap up?
Yeah.
Okay. So, so I'll not go into main findings about everything. What I'm going to do is very quickly take you through what does it mean, these findings for message design, for example. So at the strategic level, I think appropriate message design in terms of content and wording should be made mandatory for planning level by NDMA. Capacity building workshop for effective message design must be organized. And at the tactical level or at the state level, I would say ensure following content in warning message include cyclone attributes such as severity, land. These are there, but in the first message by IMD, but by the time it reaches the last level, we found that it disappears, a lot of this information. And inclusion of uncertainty and training, at the operational level, that the message quality does not deteriorate by the time it reaches the last mile is extremely important. Developing channels of warning. I think here I'll very quickly skip, but basically, because it's the last mile person, it's really at the village level who's much more believable. I think it's extremely important to involve them in these meetings which happen before the start of the cyclone season, so that the entire thing is understood by them and there is no deterioration in the quality of information that finally reaches the last mile. Timing I will skip. What I'm going to do is talk about integrating past impact experience in disaster management. We found that past experience is of three kinds. One is your past experience with the warning itself. That means, did the cyclone occur given the warning, and did it occur with the same severity? Did it occur with a different lower or higher severity, and so on? That really affects the quality of response in the current cyclone that is going to occur. The second is about past experience in terms of stay in relief shelters. Past experience in terms of stay in, okay. So your quality of stay in relief shelters can really, really affect how you're going to respond in the next warning. I think I'll stop here for the time being because there is much more to be shared and with less time. But just to give, I hope you got the flavor of what I was trying to get at. Thank you so much. And thank you for giving me this opportunity to share the stage with all the eminent speakers and panelists. Thank you so much.
Thank you. Thank you. That was so relevant for us as we are, implementing a big program in National Cyclone Risk Mitigation Program, both the eastern and western coast. Some of these findings are very, very helpful in developing our strategies. We are really short of time. We have two more speakers to go. So I now invite Professor Mr. Rohit Magotra. He is Deputy Director, Integrated Research and Action for Development, New Delhi. He is joining online. Mr. Magotra, can you identify yourself? It would be good to see you on the screen. Okay.
Thank you,
Good.
sir. And am I visible and audible both?
You are visible and audible, loud and clear. Very nice.
Thank you so much, sir.
And I just request you to be brief because we have two more speakers and I have been asked to conclude this session at 11:30. So if you could be, just briefly make your points, I think that would be so good. Thank you.
Thank you so much, sir. So the topic which I'm going to present today is on climate adaptive detection plans. So I think now we haven't seen any such debate happening across the globe, both in developing and the developed world, on the heat. How the temperatures are rising and how they are impacting the lives of common man across the globe, and as I said, both in developing and the developed world. And I'm happy to share that the leadership which India has taken in terms of developing adaptation plans with respect to the heat is very prominent. And as an institution, we are also supporting both NDMA in further delineating the heat action plans in India and developing and implementing these heat action plans. So So very relevant topic. That's what I want to share, which is of interest across the globe. So I represent an institute called IRADE, Integrated Research and Action for Development. It's a 20-year-old research and policy institute, and climate change, energy, urban development, and also agriculture and food security. These are some of the areas which we work on. So as a center of excellence, Ministry of Housing and Urban Affairs, so we have engaged with more than 19 states and worked on several aspects of disaster and climate resilience. So we work on climate resilience, disaster, health resilience, and urban infrastructure services. And several engagements we have with the DST, Ministry of Environment, Forest, and Climate Change, and several other state and city authorities. So as I said that, rising temperatures are, a concern across the globe, and it's not something which is just impacting the human health. It's also affecting our ecosystems and the communities who are depending on this ecosystem. So their livelihoods are being threatened because of these, and as well as the economies. So there is a lot to be done with respect to our action on the heat, and that's where we thought, like, how do you transform this knowledge to action? So we engaged with the three cities in India, which is Delhi, Rajkot, and Bhubaneswar, to help them develop climate adaptive heat action plans. So this engagement started way back in 2018, and we engaged with these three cities to develop first ward level heat action plans. So on the preparedness side, I will just tell you that that India is also going to face the high impacts of heat waves. So as projected, we have seen that the number of heat waves have risen from 7 to 32 on average number of heat wave days. And geographically also the spread has increased from merely 9 states in 2015 to 2019. So hence there is a need to act with respect to action on the heat. So these are some of, examples of the heat waves, how they have affected the world. So around 1,700 people killed in Spain, Portugal, and this was last year. And we have this huge village which got burnt in Canada, which was threatened. So these incidents are not sporadic, but across the globe. And South Asia per se is huge, highly vulnerable. This Jacobabad in Pakistan, that is fairly crossing the wet world temperatures. And very recently also it was close to the very high wet world temperature. So primarily, the survival even in those areas, continuing living in these areas is also threatened. And this is something which we are likely to face in several regions of the world, and South Asia more often. So these are some examples of heat waves. I'm just going to skip all this. What I'm just bringing your attention that it's not only the health part, but it's also affecting the ecosystem, the marine ecosystems, leading to the deaths of a lot of fisheries population, and this was high departure within Antarctica, which you face. So these are some instances, and this is India, and this is this year of March 2022. Summer came very early, and it started impacting our hilly areas more compared to the plain areas. And as early as March, we are facing with the heat waves in the region of the Himalayan region in Himachal Pradesh and Jammu Kashmir. So summers are arriving early. So that's where the preparedness also needs to be, preparedness also needs to be kind of taken earlier rather than, later what we're facing in April, May or June. But now that situation we are facing in the April. So globally also, as I said, that due to the climate change, the wet world temperature are likely to rise, and that's where the threat to human existence is there, as well as to the ecosystem. So it's very evident that, how do we kind of adapt to the impacts of the climate change, and that is where I'm just kind of give you a context that why heat wave action plans are required and important. So many of you know that it's a relative phenomena. Heat waves are relative phenomena, and in India also we have various criteria to define these heat waves. So this also varies region to region. For example, in case of a coastal city like Karachi in Pakistan,
Mr.
our
can you
heat wave
conclude
action
in-
plans.
Can I request you to conclude in 2 minutes because I have one more speaker to go.
Sure,
So-
I'll try to be I'll try to do that faster. So what I wanted to emphasize that heat wave action plans are critical adaptation measures to growing the heat, and that's where we're talking about. So there are 4 major components which are early warning, the public awareness and the community outreach, capacity building of the various institutions which are involved in terms of both the medical stakeholders as well as city authorities, and then from the mitigation point of view, looking at the reducing the exposure and the impact from the heat, taking long-term measures. So why these are important? Because they prevent deaths and they reduce illness and they actually make the cities future ready. I'll just come to the kind of methodology which is used to develop these heat action plans. So we look into the local factors with respect to the climatology of the city, and this thermal hotspot mapping actually provides the differential temperatures within the city. So it's not like one straight jacket solution applied to across the city, but looking at the identify specific locations within the city which are actually heat hotspots or the urban heat islands in the city, and further to identify the vulnerable populations within the city because they are the ones who face the most impacts because of the heat. So these are the actions which we are taking at identifying the local vulnerable heat hotspots as well as the local vulnerable uh, population which is going to be affected due to the heat stress, and taking accordingly the action with respect to that, and obviously which is achieved through the stakeholder engagement and implementing the strategies. So this is a map where we look showcasing the heat hotspot within the city. So this is important to identify such urban heat islands so that the action is focused on actually prioritizing the actions on in those spots and increasing the preparedness rate the same. These are the future scenarios. So it's a one case example where you're looking at the temperatures in May 2018, where only one ward is severely vulnerable to the impacts of the heat. What if you look at the 3-degree scenarios, we are looking at mostly all wards, which are becoming extremely vulnerable to the heat. So that is the kind of the warning the climate has, and that is where the need is to prepare more and also focused and targeted approach to the heat. So this is the process as I was talking about the heat. So we have identified and developed heat vulnerability maps on the basis of the action can be taken.
Mr. Malhotra,
Just last minute, I'll just take the last minute. So this is something where we looked at the heat thresholds for the city, and we identified, that these heat threshold needs to be identified at a city level and maybe at the ward level, so that the heat waves are announced earlier in these localized wards, and the action can be taken. So these has been implemented in cities of Rajkot, Bhubaneswar, and moving forward, we are taking it to. So action has been taken by the municipal corporations in both building awareness and the actions. So a lot of these material is available in the public domain. So moving forward, we have taken these climate adaptive action plans through South Asia Heat Health Information Network. So more can be provided and shared with the esteemed audience. And I thank you, Chair, for exceeding the time. But
Thank you very much.
thanks so much
very
again.
much. Thank you. So quickly, now Dr. Janki Andharia, you are the last and the best.
Okay, I'll try to be the best.
Yeah.
Okay, I am It's 11:25. Been around for the last 2.5 days. So my pitch really has been to speak more in terms of what has been missing in the last couple of presentations. We have generally seen people talk about systemic issues, refining models, and sort of talking about what is going to happen. I think what I found seriously missing in much of this discussion is, and I think I'm glad that Dr. Shukla actually mentioned that we need to really understand the differentiated nature of vulnerabilities. So my argument is that we need to put the poor at the center stage of climate resilient DRR. So this is my key message. The second issue, I'm sorry, I think the colors look sort of odd out there, but the colors were different. And I'm sorry that you can't see it, but
those are better here.
yeah, they're better. Anyway, but
No,
I,
for audience, they're
oh,
better.
they can see? Ah, okay, okay.
Yeah.
Only for us, it's bad.
Yeah.
All right, all right. So the question is, where are the poor and the marginalized in the typical systems thinking and models? I think this is my key question to all those of the participants, presenters, scientists working on this theme. I have about 10 slides, but I will not go over all of them. I anticipated, because this is what has been happening in the last 2.5 days, all sessions overrun and so on. So I had a feeling that if I just have to present something in one slide, which would that slide be? So I have maybe 2 slides, the first and the last I'll present. So we need to recognize that growth has never really been inclusive. So inequality has in fact increased, and most of our models assume that people are all equal and everyone's going to be equally impacted with climate change and so on. And I think we need to really put this on the table out there and recognize that the poor are going to be impacted severely. And what is it that we have to offer is a $1 million question. So we also know that 70% of the people killed by disasters were classified as receiving low or lower middle income. Countries with the fewest resources are likely to bear the greatest burden of climate change. We need to sort of really put it out there. And I would really sort of demand of the systems models that we saw to disaggregate their models to really be able to say, how are the poor actually impacted? I think that's something that I would like to see. Otherwise, all of this science is meant probably for people to gloss over the real impacts. And I think that's sort of something that we need to reflect on, and I hope we discuss that a little further. So there's a real threat to the poor, and the question is, are the poor now going to be a dispensable entity? So while within sustainable development discourse, we talk about inclusive growth, but growth has really never been inclusive. And we recognize that climate change is going to, and all of this is known, that it's going to reduce access to drinking water, negatively affect health of poor people, food security is going to be impacted. I think we talked about, I mean, all the various missions that are instituted by Government of India. But the question is, how are those missions performing? And that's my second question, which is really a larger question. And I hope people who belong to the government systems who are here in this room would actually sort of respond to this question of what is the accountability that governments have to ensure that things that are already known, we are going to be able to fix. So are we going to address issues of poverty? What about development planning? What about social protection? So who's going to answer those questions within the climate change and DRR discourse is a question. So when there is loss of land mass in coastal areas, all of this, which we know, people have no choice but to migrate. And then we pose the urban question as if it's, something which is, something to do with congestion and so on, but not necessarily about livelihoods and survival of the poor. Okay, I think I can just sort of stop here. So disaggregated, differentiated consequences need to be mapped, and Dr. Shukla's presentation actually spoke to that. And we talk of human well-being, but human well-being is not a homogeneous whole. The well-being of people in this room, which is probably 1%, top 1% of the country, is very different from the person who's the poorest out there, maybe a struggling laborer or a woman or a disabled person in maybe a tribal area or a village. Okay, so what is it that we are really concerned? Is there a value framework to our climate resilient DRR? So what is the ontology, epistemology? What is the underlying message? You know, what is it that are we really looking at integrating adaptation responses into development planning? Who is going to do that is a question. So where are the ethics? Where are the values? What is the worldview that we adhere to? I think we also know that our utilitarian approach to development continues. Profit maximization is the mantra, whether we like it or not. And more we are seeing that social protection and issues of inequality are being thrown out of the window. So positioning of social justice and equality, absolutely central. The dimensions of governance, we talk about governance as if it's an apolitical process. So let's bring issues of politics and institutions and actual practice. We keep hearing about this, that we have all the laws, we have all the schemes, but implementation is a problem. But why is it a problem, and why are we not fixing it, is a question that we need to really debate and discuss. And I sort of feel bad that very often government officials come and then sort of leave. So the general sort of approach is that within government systems, I hold my position, maybe as a secretary or whatever. All I need to do is hold my position, stay out of trouble, continue business as usual. So what is the science doing to actual practice and implementation at the decision-making level is a question that we really need to discuss. Because this country has no dearth of models, pilots, excellent experiments. Dr. Gupta actually talked about this, that we do have manuals, we do have books which tell us how wonderful these pilots are. So then what's the problem? And I think unless we get to that, we are going to continue to remain in deep trouble. And the question is, where's the commitment to assisting and working with the poor on part of government, civil society, private sector, and in helping poor cope with the vulnerability to climate change? I'll stop there. Thank you.
I think that's a very challenging note to end this session. She raised so many pertinent questions. I wish I had the time to engage with those issues. These are very, very important issues for our policies. They're also very important issues for our moral existence. How we choose to ignore poverty and inequality in our work. It's a very complex question. One thing we say that there is, and there could be several responses to it. One, of course, is that we are occupying privileged perch, and we are very jealous about that. We don't want to leave that privileged perch. And we really are more concerned about ourselves. We tend to be selfish. That's that's one answer. The second answer is this, that yes, we respond to those issues, but there is always a lag, that we, whatever the issues are, there is always some delay, there is always, some, I would say, lag in the way we respond to those issues. Third, that we often engage with the symptoms. We do not really always address the malaise, so the very underlying issues. But also one can say that these things are changing. it's a highly dynamic situation. If you look at the practice of DRR and climate change, I wish I had more time to address this issue. It's very important. 2000, I mean, both Dr. Andharia and myself, both of us have great together in this field. 1995, I started working with her, when I was working in the Latur earthquake. So it's 27 years now. 27 years, DRR, the practice of DRR, has it evolved? Hasn't it evolved? I think it has evolved a lot, if you see this, where we are from compared to 1995, But our problems have increased manifold. The vulnerabilities have become more magnified. People's expectations have increased, and we have not responded to some of those emerging issues with the same level of urgency as we should have. But I think there is a lot that is happening. I mean, I say that issue of displacement is very, very important. It was raised by many. We just developed this policy of resettlement, mitigation and rehabilitation of the people displaced by coastal river erosion. It will just be circulated. It's the first time we are developing a policy. UNICEF is working with us on this issue. After a long, long time, first time we are developing a policy on erosion. It should have developed 10 years back. So there is a lag there. So it's not that we are not responding to the issues, but I think there is a certain amount of delay in the way, and it happens because there are several levels of policy making. There is a state, there is a local level, there is a state level, there is a national level. There are so many stakeholders, bringing them together, getting them to support all these things. It's a huge, huge challenge. I work in the NDMA. I face this challenge on a daily basis. So I'm not going to discuss those challenges here. But I can say that, that when you are working at a certain level, bringing together different pieces and turning them into a viable policy, the challenge should not be underestimated. So thank you very much for all the great, I think, the presentations today. They were very, very timely, topical, relevant. They concerned with the poor. They concerned with those who are living on the margins of the society, those who are differentially impacted by vulnerability. And I think, we are taking a lot from these presentations. I wish we had more time to discuss, but thank you very much. And great, generally the panels are dominated by men. For the first time, I see the panel is dominated by women, and I really enjoyed chairing this session. Thank you very much.
Thank you, sir. We have reached to end of the session. I would once again like to thank you all for gracing us with your presence. Sincere apologies for the initial glitches. But before we part away, on behalf of TIFAC and IIASA, I would request the chair to felicitate our honorable speakers with a token of appreciation.
Thank you. I think start with the... Okay. Thank you.
Thank you, ma'am, for being with us. Once again, thank you, speakers who are joined us virtually also. So, good. At the end, I would request Dr. Yashwant, sir, to felicitate our chair. Thank you so much, sir, for moderating the session. and driving out the discussions so keenly. Thank you so much, sir. Thank you, everyone. We can assemble there for tea.
I would propose for a group photo.
Sure, group photo.
All can join.
Wonders.
Please.
Have you visited NDMA in the recent past?
Yes.
Yes, sir.
I did, for this adaptation communication report.
Okay,
So
okay.
I did visit Kunalji.
Okay.
All can join, please. Yeah, please come. You can also come.
Such a pleasure meeting you.
Same here. Please come again.
Madam,
And I would like
you can also
to
join.
get to see your presentation in this much greater. Yeah.
Most happy to
Yeah,
do so.
yeah. Please come.
Please come. संगीता जी आप भी आ जाइए.
आ जाइए मैडम. आ जाइए. मैडम करीब में आ जाइए तो एक और वहाँ पे. कुछ लोग सामने भी आ सकते हैं. आई थिंक इट
सर आप प्लीज वो पीछे आ जाइए.
थैंक यू.
Thank you.
एक किसमें हाँ क्योंकि इनसे तो फोटो बहुत बाद में मिलेगा. मिलेगा भी नहीं मिलेगा वही पता नहीं. कॉन्फ्रेंस होस्ट से बहुत मुश्किल होता है मिलना. Thank you.
Thank you.
Thank you.
Thank you. So please do come.
Thank you, sir.
Yeah.
My card.
Yeah, sure.
Thank you.
Thank you. Thank you. Hi.
How are you?
Hi, how nice to see you. So nice to see you.
Oh, good. Huh? So are you going to tea or are you going on? Let us talk a little
Yeah,
bit.
sure.
Hello, Dr. Vats.
Hi. How are you? Yeah. So here I got a message from Ashokji's friends about this what you talked about.
Audible? Check my audio also. How many minutes you are giving? 10 minutes. Okay, so let me modify my presentation. Okay.
Okay, sir. Thank you.
Bye. Bye. Bye.
related policy making. It's really a privilege to extend my warm welcome on behalf of TIFAC and IIASA, who have clubbed all of us towards this whole theme of sustainable development via a systems analysis approach. To start with the session, I'd request the chairperson to please be on the stage, Professor A.K. Gosai, sir. He's a professor in the area of water resource engineering and GIS technologies in the civil engineering department at IIT Delhi. Professor Gosai pioneered the climate change impact assessment on Indian water resources that was incorporated in the 2 national communications made to the UNFCCC. He was a key part of the expert committees appointed by the National Green Tribunal. So, sir, the topic with which he'll start is early warning systems framework using digital twins of the river. Over to you, sir.
So a warm welcome to all the participants and also the people on the panel. I think majority of them are on virtual, but still we have 2 speakers who are with us. And I'll welcome all those people who are joined in a virtual manner. This session is on the water resources management, how we can manage this very precious resource in a better manner. So the topic which I have decided to talk on is basically the early warning system, which is a very key necessity under the SDG 6 goal, where we need to have such systems in place so that we can provide adequate warning for the areas which are going to be coming under flood. But the way we have put this system together, it can play many more roles. So I'll try to, maybe in a quick manner, give you a glimpse of the kind of work which has been done at our end. Can you put the slides, please? See, water resources management is a very complex issue, and it becomes more complex the more demands we have, the diversified demands. And in many cases, the demands which are coming up, we only recognize the conventional demands of agriculture, the domestic and the industrial demands. But when these demands are put in place, how they grow in size, that nobody knows. We normally lose track of that. So I think the major issue when we try to manage the water, you have to keep cognizance of not only the availability, but how the demand is changing and at what stage the demand has grown beyond the availability. That is where all of us are finding difficulties. And that's where the attention has to be put. Next slide, please. What we had done is that to take care of the requirement of the early warning system, you need to understand your system first. And in this particular case, the system is confined by the river basin. So each river basin has to be understood. And these days, the models are available. We can also call digital twins. The extent to which we can put the implications or the implementations of water use into the model, that is where the main issue is. So you have to have models which can have the capability of mimicking the natural processes, all the natural processes, so that once validated, they should be in a position to tell you what is in the offing with respect to the climate change or with respect to your changes which you have imposed as a man-made actions. So from the requirement of the early warning system, we are using these systems to translate the precipitation, which many a times is available. Maybe the scale of availability will be different, the granularity might be different, but in our country, IMD has been doing a very good job of now giving the actual observed rainfall or the precipitation which has occurred in different parts of the country, as well as not stopping there. They are also providing a good precipitation forecast. They are using different models to give the forecast. So that is what they have made available to us. And we are using those forecasts to provide the early warning to different river systems. Next. So to set up the whole model, we have adopted the SWAT hydrological model, which is Soil and Water Assessment Tool, is a freeware, is a public domain model, which is much better model than many other hydrological models, only because of one difference, that this is the only model which embeds the crop growth into the model. So you can now try to find out that one of the major utilizer of your water, which is agriculture, you can also afford to simulate that, knowing what you are doing with the agriculture, what kind of irrigation system you are having. So all that can be incorporated in the model. So you can come out with a very good prediction of what will be the crop yields if your model is working all right. Not only that, you can also go to the extent of taking care of the non-point pollution. How much fertilizer you are using, how much pesticide you are using, what is their fate, whether they are more, the dosage is much more than required, and the remaining dosage will come into the groundwater or the surface water. Next, please. So the model mimics all these natural processes, and this is the kind of data which is being used. I think many of you might be aware of that. So all kinds of data, which is the data on the weather conditions, the data on the soils, data on the land use, the terrain data, as well as the interventions which we have made in the land mass, whether in the form of big reservoirs or medium irrigation projects, diversions. All those things have to be incorporated to really bring the baseline into picture, which is the true baseline as per your present situation. Next. And these data are also used to validate the model. Whatever you are observing at a particular location, which is the location where you are having the discharge measurements done by the Central Water Commission, those points are the points where you can also find out that if you run the model, if you simulate the conditions, what the model will produce at those locations, and you can compare what the model has produced and what the actual observed flows are. Similarly, you can also measure the soil moisture, and that can be also a valid checkpoint. Next. So this is the case of Mahanadi. I'm just taking one case, one river basin, where we have captured all the terrain information on the basin, the land use, the soil, and all the projects, and the grid, which is the observed rainfall, which becomes available from India Meteorological Department. So all these are captured and taken into the model. Next. And this is again the same in a more visible manner. These layers have been shown. They are GIS layers because the model is having a GIS base, and you have the digital elevation model. Next. So it captures that what is the characteristics, what are the characteristics of the biophysical characteristics of the area. The land use is very elaborately incorporated. Next. Likewise, the soil layer, next you can go to. Then the model divides the whole area on the basis of these information into hydrological response units. So if the precipitation falls on a particular area, the fate of that precipitation is dependent on what kind of land use it has incorporated, incurred. what is the soil behavior in that segment. So when we intersect these, the terrain, land use, and the soil, we come out with those units which are known as hydrological response units. So they become the basic modeling unit, which if the rainfall or the precipitation falls in that area, it will behave in a similar manner if the land use, the soil, and the terrain is same or similar. That's how the whole area is divided into thousands of smaller segments, and that is the basic modeling unit. Next. Now the model works on that once we impose the weather conditions, and then it generates what will happen to what will be the fate of that, the water in the form of precipitation which has occurred there. And then the other properties take over, that how much of that will flow as a surface runoff, how much of that will go into the deep storage and act as the groundwater, and how much of that will flow back into the river system as the base flow. Next. So then, having done that, the major projects are implemented. What is their functions, how they operate, how much water is taken from them and put as irrigation water in different areas, because that changes the local hydrology. If you're putting additional water, that is something similar to artificial precipitation, that you have imposed that much additional water. So that is what is also taken, because that is the ground reality. So that is also incorporated in the model. And next, go into that. So on that basis, then we validate the model, and that's next slide will give you the kind of validation using all those, the flow observation points. And the green means that is satisfactory or more than satisfactory, whereas the green, the color is yellowish, or so there you have got some validation which is not is still satisfactory, but is not as good as the green color shows. So invariably, we have been able to, in this particular basin, we have been able to reproduce whatever the nature is doing, including the man-made actions also incorporated. Next. You can go to the next. I think this is only the depiction of the same thing in the form of. So now with this model available, we are in a position to run the model using the past information on the precipitation, which is observed rainfall, which is being given to us by IMD. So IMD, I think we are very thankful that the IMD has been producing that information. And they are using two models, which is one is the GSF and the other is one model gives the forecast for around 4 days. The other model gives the forecast for 6 days. We are using both the forecasts and then coming out with that any location in that basin, which is the area of your interest, what will be the flow at that location using the observed rainfall of the last 2 days and the forecast rainfall of the next 4 days or 6 days. And that information is available now. Now you see from the angle that this is early warning, which is given to the area, which is available to the area. And this early warning can be acted upon by the people of NDMA. They can know in advance, even if the rainfall forecast is an error. It can be is a forecast after all. Still, the observed rainfall, which is made use of, that will provide you on the basis of the catchment lag, because the rainfall, the precipitation will take some time to travel from the basin to the location of your choice. That is what is the catchment lag. And the catchment lag for basins like Mahanadi can be as good as 1.5 days itself. So you, in any case, knowing the actual rainfall, just depending on that, still you're having a warning of around 1.5 days because you have used the rainfall runoff in conversion. So that is what is something which is now very useful, made available. Next. This whole thing, we have done the whole all the basins of the country. We have validated them and we have put them in a portal, which is, there's the link for the portal. This is done by IIT group as well as the INRM, which is a incubated company of the IIT system. And they have, as a joint effort, along with the IMD, we have created this particular portal which has this information available. So we are simulating the whole country every day. Every day when the new rainfall forecasts come, we simulate the whole country and put this information in the portal, which can be, which is a GIS-based portal, and people can just go to it and find the area of their interest, the catchment or the basin of their interest, and find out what is the status of the flood in that particular location. Next. These are some of the depictions of the portal showing the whole country and then picking up a specific basin and then going to the level of that at a particular location in the basin. What is the forecasted precipitation as well as what is the resultant flow which is possible because of that precipitation. So every day it is updated. If we have done today, tomorrow, the 1 day ahead forecast will become the observed rainfall. You can also compare that how good it was. And that is working very well. Next. Now, this is one part of the story that when we are trying to look at the water resources management, this framework which is available with us now, it has all the basic ingredients in terms of how the hydrological regime of that basin is, how it is functioning. You can go to the extent of using the same framework for reassessing the availability of water under the present conditions, as well as under the future climate situation. We have done that, and that information is available in a different manner. You can also go for assessment of demand imposed. How much is the actual demand? And that you can incorporate in the model and find out, is your demand going beyond the availability, which is very scary? That means your system is under stress. And this can be used as a feedback mechanism to the policy making, that what kind of actions you need to take to manage the demand, because the water resources management is now more about managing the demand. Unless you manage the demand, if your demand has gone beyond the availability, you cannot survive. It's not sustainable. It has to be dealt with. So from that angle, I feel when we are talking of system models, yes, they are useful, but they cannot provide you a good recommendation if the basic information which you have put in the systems, in understanding the systems, is flawed, is not validated. So that is where I feel that before we really start with the system approach, we need to understand our systems in a more realistic manner. Next, please. So all this information which is required for, as I have said that between the competing demands, what is the overall demand, and what are the trade-offs? How much water you can take out from the agriculture sector, which is having around 85% of the utilization, and what you need to do to really extract that water, what kind of help the farmers need, how you have to change the irrigation systems, what is the investment required for those systems. So it's all policy issues. And once the policy is made, but here in the simulation mode, you can actually go in for assessing which are the good options. You can compare the options and then you can come out with that. This is a better option. Similarly, if you have to take care of the environmental demand, what is the environmental flow assessment you have to do? You have to again go back to the same framework. You have to find out that what is the environmental flow in this particular basin for different river systems. And then only you can you can impose those. But then the second question is that from where it will be coming, because there's additional demand which we have never fulfilled so far. Next. So finally, I feel that the integration is possible if you have the mechanism of, you have the frameworks of this kind, which can take on all the segments of your water use or your demand, and then you can find out. And one more thing, many times we are not able to see everything unless we use the scientific tools. For example, what is the surface water groundwater interaction? Now, if you're extracting more groundwater, you're lowering the groundwater table. That is changing the hydrological regime. Many of the streams which were gaining water from the groundwater, now they are losing water to the groundwater because the groundwater table has gone so low. Those are things which are not going to be visible unless you use these kind of frameworks and scientifically prove those things and create evidences. So I think in the coming years, next please, that's my last slide most probably. In the coming years, what we need to do, if we need to really bring some synergy and some sense into our judiciousness into our actions, we need to have a lot of monitoring and evaluation of our systems. We need to create sensors, have the information which can be vetted, which can be used to validate your these kind of frameworks more, and then create evidences which can be used by the policymakers. Because right now our policies are being made without any scientific evidence. That is where we need to really take care of those situations and bring out mechanisms where the integration, we have been harping about integration all along these years, but we have never reached there even now. We cannot say for sure that though we have created committees which are having people from different ministries, they're made to talk to each other, but they don't have a mechanism where the information can be shared and it can be integrated at the information level, at the databases level. That is what is needed. So I'll stop here, and I think we'll try to first listen to all the people, and then have question answer session later on, because otherwise some people who are going to come in the end, they will be the loser. I don't want that to happen. So we'll go by this list which is given to me. The first presentation is by Professor Danya, who happens to my colleague, a very brilliant researcher. Professor Danya, are you there?
Yes, sir. Good morning. I hope I'm audible and visible.
Yeah, you are. You are visible as well as you are audible. So please, you can start with your presentation.
Yeah, I understand that we are running short of time. So can you please inform me how much time I should take?
I think 10 minutes is okay. 10 to 11 minutes. I'm trying to keep some time for discussion later on.
Okay. So I'll be very brief then. I'll just
take 10 to 12 minutes.
Yeah, sure. So good morning, sorry, good afternoon, everyone. I'm Dhanya, and I am an associate professor in Department of Civil Engineering, IIT Delhi. And I will be speaking about the topic on how we have addressed or how we have been addressing the water security of NCT Delhi, and what is our approach and so far been, and the challenges we have faced and we have been facing, and some of the way forward according to our experience so far. So in this one, as I mentioned, I will be highlighting the problems faced by NCT Delhi as far as water security is concerned. And I'll be giving you the glimpses about the research activities we have done. I may not be going into the methodological frameworks we have developed and the technical aspects of that because of the shortage of time. So when it comes to water security, the very first thing we have to do for according to one region to another region, the very definition of water security also may vary. Water security is a term where you can actually put all the terms, other terms. You know that when we take water, all other areas are interlinked. So all other terms like climate change, food, energy, all can be put in this security. So it is as utmost necessary for us. The very first step is to define fix a proper definition of water security pertaining to the area we are considering. And when we define that, we have to also take into account the term sustainability. The technologies or the frameworks or the policies we are deriving should be as sustainable as possible. So when it comes to the NCT Delhi and the water security, the most acceptable definition we come up with is water security should be reliable access, and water security should be talking about the water of sufficient quantity and quality, and it should address the risk faced by people, not only people, but environment and also economy. And this is a part of the definition given by Gray and Sadoff in 2007. So we found these factors acceptable and we went ahead with that. So when it comes to NCT Delhi, the major problems, and in fact, in short, NCT Delhi is facing almost all the problems, all the water-related problems any region can be facing. So first of all, insufficient raw water and inadequate and inequitable distribution of water supply, and inadequate coverage of water infrastructure, the three infrastructure, water supply, sewerage, and storm drainage. All these three water infrastructure are inadequate. I'll show you the next slide, the details of those. And non-revenue water in terms of inadequate tapping of water and unlawful tapping of water, and also in terms of losses and all, and the poor water quality. We know the stretch of Yamuna passing through Delhi is the dirtiest one in the country, and also risk and adaptation in terms of health related risk, in terms of groundwater declination, in terms of urban flooding, all such kind of risk. So when it comes to the inadequate raw water, we know that the NCT Delhi should have been fed only by Yamuna, which is a feeder basin. Now also we are tapping around 39% of water from Yamuna, but because of the sudden abrupt population increase and the demands of the capital city, we are also tapping water from the adjacent basins of Ganga and Bhakra, and a percentage also from the groundwater, which cause its declination. So even if we are tapping water from the adjacent basin, still if you can have a look at the amount of water demand and the water availability, still we are short of around 300 or 400 mgd. And there is some possibility of utilizing the unsafe water resources in terms of reuse, retreatment and all. So in terms of the sewage generation, it is around 4,000 something, and we can use those sewage generation in terms of by treating that water, and whether it can be used for, whether we can reuse that water for some sectors, that can be explored, and that particular water can be used, could be used for for satisfying this deficit, whatever we are seeing here in terms of demand and availability. So in short, these are the problems being faced, and coming to more explanation of these problems, as I mentioned, the stretch of Yamuna passing through Delhi, that is 22-kilometer stretch, is the most polluted stretch in the country, and which is actually joined by around 15 to 16 drains from the NCT Delhi. So the Yamuna, 80% of the water quality is deteriorated in this particular stretch. So how to tackle these? And as I mentioned, the inadequate water infrastructure, you can see from these three pictures that how the water supply network and how the sewerage network and how the stormwater network is inadequate. The color shows its spread. So that means wherever that color, particular color is there, green, brown, blue, there the infrastructure is there, other regions it is lacking. Even though the color is there, the inadequate maintenance of this infrastructure may also result in the inefficiency of the system functioning itself. So how to tackle these? So first of all, before going into any framework and all, we first of all post some questions, and those questions we keep on refining those questions, and based on those questions we build scenarios, and from those scenarios probably the government agencies can modify the way it is functioning. So first question, the questions are very simple, but when you try to address those questions, the complexities evolve. So how much raw water can be made available to NCT Delhi from different sources? Ideally, it should be fed by the feeder basin, right? So by the business as usual scenario, And if you are prioritizing the NCT demands by being so selfish and by prioritizing the capital city demand, how much of raw water can be extracted by probably sacrificing the other needs? And as Professor Gosain also mentioned, we pay least attention to the environmental demands, but if you're prioritizing the environmental demands, then how much raw water can be made available to the city of Delhi, and also by improvising the efficiency of the upstream system. A lot of water is being lost due to improper irrigation planning and to conveyance losses and all. So if we tap that, if we stop those losses, and how much can again be made available to the raw water. Now, second question is that even if we are making sure to make as much as raw water can be made available to city of Delhi, then also with the existing resources. As I mentioned, there is a lot of sewage getting generated. So there is reuse, treatment, and recycling of water. How much we can utilize that? So with the existing resources, how effectively the city can manage its resources through water treatment, reuse, and recycling. And in that also different scenarios we can work out, a combination of scenarios. That is possible saving of water during the treatment process, effective utilization of reuse of treated water, and the possible saving of water during the operations, that is pipe leakages and the wastage in the household. We all use RO and a lot of water is getting wasted. So if we give proper attention to that, then a lot of water can be saved. So scenarios like that. And the possible ways of groundwater enhancement. All of us are very well aware of the rapid declination of groundwater and which results in the deterioration of quality as well. So rainwater harvesting, curtailing the groundwater pollution, etc., etc. So that is second layer, which encompasses the first question we have addressed. And the third is that these two questions, even if we address, there is a layer of uncertainty created by the changing nature of climate recently. So what is the scenario of water availability going to be in the future when compared to the existing one? That also need to be superimposed in all these things. And the fourth one is that, which is rarely addressed, we feel, that is how much the city, what is the allowable size of the city? How much the city should be allowed to grow? Ideally, the resources should meet its demand. So the resources should be actually greater than the demand from any particular region, which hardly is the case nowadays. So what is the allowable size of the city in terms of population, in terms of industries, in terms of the whole demand, considering the constraint in the question? So if you actually address all these questions and a set of scenarios or a combination of scenarios should be worked out. Now, if we are able to visualize all these things, we can understand or realize the complexities or the intricacies in working out the frameworks in. So in short, we try to address the water security of NCT Delhi by focusing on all these four problems. And we adopted a framework by addressing these issues in four different spatial levels. First is we try to address some of the questions at the basin level, that is our upper Yamuna basin, which is the feeder basin of Delhi. And some of the questions, the NCT of Delhi, which is the administrative domain. And some of the questions, as you know, NCT Delhi is also divided into 3 subbasins, and one subbasin is Barapulla somewhere here. And some of the frameworks or the methodologies we're going to develop, we focus on the Barapulla basin to make it more demonstrable. And also in the Barapulla IIT Delhi campus is also placed. Some of the frameworks we focus on this. So this is a list of the activities we are doing across all these different spatial scale. For example, when we talk about the water availability scenario, how much the raw surface water is going to be available, we have to focus on the upper Yamuna basin with terms of the current and the climate change and surface water availability. When it comes to the water audit and the groundwater system analysis, we went for the whole of NCT Delhi to make it more at a finer resolution. And also when it comes to the adequacy of water infrastructure, the 3 water infrastructure, we are first focusing on the storm drain network now. We focused on the Barapulla basin. And because our campus is more approachable and we can demonstrate all those frameworks very easily, we conducted all these deployment in the water infrastructure in our campus. For example, water supply, storm drainage network, and a set of GIS framework. So now I'm going...
2 more minutes.
Yeah. So now I'm going to quickly take you through the activities we have done. So since only 2 minutes are available, all these activities in the form of demonstratable or deployable frameworks are made available through a particular website. So how much of raw water is made available to Delhi? So how the future climate change and the present condition is affecting the water scenario of Delhi that we have explained by downloading the climatic projections over the basin. And we also analyzed how the extremes over this particular region is going to change. So we know that under climate change, short intense rainfall is increasing. That we have witnessed over this basin itself. And how to tackle that is a different question, but quantifying those climatic projections was our interest in this particular one. So for example, we found that the dependable flow, that is nothing but the flow we can depend on, is in fact increasing in the upstream part of the basin, and whereas the dependable flow due to the usage of those in the downstream is going to be either the same or decline in the downstream portion in the later years, or the mid-century or the on the end century. And also coming to the groundwater vulnerability, we have found that most of the regions of Delhi, you can see the hatched portion is actually unsafe. It's overexploited, except the northern part. And that we have come up with a framework to quantify that, which regions are getting more overexploited and which regions are getting more vulnerable. And we have also developed a groundwater model to simulate the kind of scenarios which I have explained earlier. And this is the kind of system model we are developing. System model will help you to avoid all the intricacies of the physical things in the system, and will convert that system into inputs and outputs, which helps in a demand, the resource availability. So this is something which we are developing to account the climate change, pollution, and the socio-economic scenarios. And also we try to develop the water supply network. And as I mentioned, some of these works are focused on different spatial level. This particular work is focused on the Barapulla Basin and the IIT Delhi region. And also, this is one interesting activity we are doing. As of now, when CPCB and all are measuring water quality, they may focus on this stretch of Yamuna. I hope you are able to see the blue stretch. So we wanted to identify what are the hotspots inside IIT Delhi, which is contributing to this pollution. So we extended the water pollution measurement, water quality measurement over the Barapulla Basin. For now, we are focusing only on Barapulla Basin, and we could try to identify which are the major regions or the points where major percentage of contributors that we have to be identified, and this is a work being done in support with NMCG and all, led by Professor Gosai. So these are the pictures we have developed in terms of water quality, COD, total dissolved oxygen, and the bigger the legend is, that means the bigger is the more is the pollution. So these kind of spatial plots are made available to identify which region is in fact probably the culprit in contributing more to the pollution. Further, also we generated the urban flood. We also addressed our urban flood situation, and a demo model is developed for the Delhi campus, IIT Delhi campus, and also over Barapulla. This is a demonstration of how, during a rainfall, even how the area will get flooded, and this is also being supplied through that online portal. And when it comes to this one, so this is the online portal we are developing. It is launched, but it is not officially launched. But I thought that it is a good platform. This conference would be a good platform to publicize this. So we are publicizing, we are disseminating all the research outcomes to this portal, jalsuraksha.iit.ac.in, where all the toolboxes and all the frameworks we are developing is made available, the information of which are more. And this is the team behind that. So with this, I will conclude. Thank you for your attention, and thank you for the opportunity. Thank you, sir.
Thank you, Professor Danya, for giving a glimpse of the ongoing work on the water security of Delhi. I'll move on to the next speaker, which is Mr. B.P. Yadav from India Meteorological Department. Mr. Yadav, are you there?
Morning, sir.
Good morning. Good afternoon. So we have got delayed, and please make your presentation. The topic he's going to talk on is sustainable water management in agriculture and power sector, hydromet services for sustainable agriculture and power sector. Over to you, Mr. Yadav.
Thank you.
Please take around 10 to 11 minutes so that we are left with some time for.
Yeah, I will leave the time, but as was discussed with the organizers, there was a slight change in the topic.
Okay, no problem.
I will be
As long as
sharing.
it's relevant to.
I will be rather extending your presentation.
Okay.
Uh,
Okay. Go ahead. Please go ahead.
I find it very nice that you did all the development work for this workshop and also for this session. And I will be presenting the operational part of your work, which you are doing in different research institutes, how IMD using different framework and models being developed by the research institute in their operational forecasting, and what are our operational services for hydrometeorological disaster management and ultimately water resource management. So I will be focusing on that, and let me share my presentation. Uh, uh, just give me a 1 minute time.
I'll remind you after maybe when 2 minutes are left, so that you are aware of.
I will stop, sir, whenever you will say. Don't worry about that, because my presentation is not developmental, it is operational. Many of you are already aware of how the work I am doing in this field. So, sir, is my presentation visible, and am I audible?
You are audible. You can put the presentation in the presentation mode.
Yeah. Is it in presentation mode now?
It's coming up, is still not visible.
Okay. Let's see.
Yeah, now it's visible. Please go ahead.
Yeah. Thank you. So, because it is water resource management and hydrometeorological disaster, so I will be talking only of the rainfall, which how rainfall is being monitored by IMD and how different hydrometeorological disasters are being forecasted, and what are our capabilities in this respect. All you know that no forecast can happen without observations, and IMD on its own has a huge network of observatories, not only from departmental, part-time, automatic, and rain gauges and automatic weather stations, but we are also taking into account the standard rain gauges being installed by the various state government authorities, and the last one, which we call it DRMS network, and this is one where we are using the data collected by the state government authorities, so that a standard fixed network of the rain gauges across the country is being maintained every year by India Meteorological Department, and that data is being used for generating various products. Sir, you have already shown in your presentation, SWOT presentation, that because of this rainfall and precipitation, monsoon, the floods have become a serious issue for our country of the last many years. Rather, if I say 1 or 2 decades, the last 1 decade particularly, it is the flood which is causing a maximum problem over the northeast India as well as the Hindu Kush region, and the disasters due to floods are increasing every day. Not only it is forecasted, but even the observations are also suggesting that hydrometeorological hazards with respect to floods are increasing over the South Asia, including China, Bangladesh, Pakistan, India, and we have to our forecast accuracy is being increasing, but at the same time the disasters are increasing at a much faster rate. So therefore, we have, in order to cope up this change in the intensity of the disasters, we have to improve our accuracy and lead time of forecast much faster than what we are doing over the last 1 or 2 decades. There has been improvement in the forecast, but still the disasters are intensifying and changing the time of occurrence and the location of occurrence so rapidly that many times we find ourselves lagging behind in our approach. So that is where both research institutes and the operational agencies have to come together to develop models and put in operation as soon as possible. Just see, because it is extremely heavy rainfall which is responsible for most of the hydrometeorological disasters, and just last 10 years that I am presenting, the gradual, it is not gradual, it is an exponential increase in the number of events being recorded in the country, which were nearly 200 in 2010, 12, 13, 14, 15. Over the last 3-4 years, they have suddenly become 300 and 400 type of events in the country. And just see it is monsoon season. Our heavy rainfall events are not distributed across the year. It is only 4 months: June, July, August, September. And after these 4 months, even the 2 months, July and August, these are the 2 months where most of the water occur in the form of precipitation, which we need to store, forecast, to really give all sorts of application of this rainfall which we are receiving through agriculture, irrigation, and other measures. As I was telling, due to the climate change, the unexpected things are happening, and the floods are the one where the increase has been the highest. The flood events, the increase has been highest as compared to all other disasters over the last, you can say, 3 decades. And the problem is that not only the flood events are increasing, but the risk across the Hindu Kush region and most parts of the country, Northeast India, East Coast, West Coast, our risk index is very, very high. So that means we are very much vulnerable to such type of heavy rainfall events, which are increasing in intensity and occurrence, and that's why making us more vulnerable in facing them, in coping with such disasters. Sir, IMD has not any other task rather than monitoring, assessment, forecasting, and providing early warning to these disasters, and providing technical support to different agencies in carrying out the work of disaster management and water resource management. IMD, of course, by using all the surface, upper air, and space-based observations, are running various models. Professor Gosai has already told we have a huge series of models. In short range, we have a WRF model up to 3 days validity. In medium range, we have a global model of 1534 with 12-kilometer resolution, and the model has a validity of 10 days, but up to 7 days, the model has been able to give quite accurate forecast. And not only one model, we are now developed 2 more models. One is a unified model in the short regional range, 4-kilometer resolution, and another unified model, 12-kilometer resolution again for 10 days. So we have 2 very high, you can say, resolution visual scale models and 2 global models, based on which most of our forecasts are being based, and the warnings are being provided as per the WMO standards, international code, depending upon the chance of occurrence and its impact. The color code is being assigned to a particular warning for a particular region or for a particular day. This is being followed by IMD, and of course, our country is prone to disasters, and there are different agencies for taking a lead in operational forecasting. But before coming to these operational agencies, I would like to thank all the research agencies, research institutes, which are always supporting IMD and other agencies like Central Water Commission and Ministry of Water Resource in bringing out improvement in their accuracy of the various forecasts. Models I have already told you. So starting with the water management, we have to know how much monsoon rainfall is likely occurring. And IMD has developed a model, in situ model, indigenous model, where we can let everybody know what is the amount of monsoon rainfall occurring in particular region or particular part of the country. And this map is for the monsoon season, monsoon rainfall forecast 2022, where we have said the monsoon will be above normal in most parts of the country except over East India, Northeast India, and extreme Southwest India, that is Kerala. Otherwise, monsoon rainfall this year is going to be very good, and it is happening also similarly. Then we have an extended forecast system where we can give week by week, 4 weeks forecast about the rainfall, temperature, or any other the disasters. Here I am presenting on the rainfall, and the blue means the above normal rainfall, and the red or yellowish means below normal rainfall. And again, you can see it that normal to above normal rainfall is likely to occur next 4 weeks, particularly across the central India, from Odisha to Madhya Pradesh to Rajasthan to Gujarat to Maharashtra. And but our area of UP and Himachal, Uttarakhand, maybe Punjab, they are not going to get very heavy rains, but light type of rainfall. So this type of indication we are giving through our extended range model and the WRF GFS model. Next 5 days, This we are giving for different states in the color code, and for different districts. All the districts, nearly 700 districts, I am doing forecasting next 5 days forecast of rainfall and temperature in different color code, and this is being provided to different agencies of Central Water Commission, Water Resources, Irrigation departments. And by taking the amount of rainfall occurring, how much rainfall is deviated from normal, such statistics are being prepared on daily basis for the entire country, for all the districts, all the states of the country, based on the data which we have. And this is the monsoon rainfall which we do on daily basis. We can let everybody know how much rainfall has occurred so far in a particular district or a division or a state, how much it is deviated from the normal, what it should be. So this is our monitoring service, but forecasting is the main part. And regarding hydrometric water source, we talk of the flood forecasting, where IMD and Central Water Commission jointly issued forecasting. IMD has nearly 15 dedicated centers for forecasting of the flood, not only flood, forecasting of the rainfall in the river basins, nearly 153 river basins, for which we provide next 5 days forecast to the Central Water Commission about how much rainfall will occur. It is quantitative forecast. How much millimeter of rainfall will occur, that type of information we are sharing with the Central Water Commission. And of course, we have a huge number of models. And recently, we have started the probabilistic forecast also for providing this service to the Central Water Commission and in the different color code. And we are sending to the Ministry of Home Affairs a one-page bulletin, which are the river sub-basins where the action is to be taken by NDRF and NDMA. So depending on the color code, red, orange, yellow, this one-page bulletin is being sent to the Home Ministry and the disaster authorities. Our accuracy,
2 more minutes.
we all know. Yeah, just 2 to 3 minutes. That goes. I will finish myself.
Okay.
Recent service we started is a flash flood. This was not being done by the Central Water Commission. They were doing only river forecasting. So IMD had taken a lead in developing a model for forecasting of the flash flood in the different in the watersheds, because flash flood is too small, too rare, too localized, too high intensity rainfall. It cannot be on the river basis. It has to be on the watershed basis. And IMD as of now has the capability to provide flash floods for nearly 1 lakh watersheds across the country, and not only country. We are at the regional center to provide such type of warnings for the flash flood, even for Bangladesh, Nepal, Bhutan, and Sri Lanka, because they do not have those models. So therefore, we are their forecaster for flash flood. They depend on our input for this. And here, the satellite estimated rainfall, the gauge estimated rainfall, radar estimated rainfall, in addition to the runoff models, the soil moisture estimation through satellite estimated soil moisture. Different products are being generated, different models are being run. In one model, there are 10 models are being run, from soil moisture to runoff to temperature to flash flood model. And then ultimately, we come out with the 2 products, which we call flash flood risk 24 hours in advance and flash flood threat 6 hours in advance. And here we can give very precise information, sir. Recently, Uttarakhand has got some flash flood. We could predict the name of districts. We are mentioning name of districts, but we can also mention the name of the watersheds. And the purpose of this is that we have to identify. It cannot be a large area. Flash flood had to have a very small area. So we pointing the districts where the flash flood can occur. This is entire Maharashtra coast. We only gave warning for Ratnagiri and Sindhiguru, 2 districts, that there is a flash flood possible, which has actually happened. So our purpose of flash flood is that from a general warning for a large area, for covering entire west coast, that type of thing, we have to pinpoint the 2 smaller areas, the watersheds, the districts where it can occur. And we have that capability now through this model which we are using. City-specific rainfall forecast models has also been developed. Of course, IIT playing a role in developing such models. We call flows. We have developed the flow models for Mumbai as well as Chennai, and these are in operational, where the localities or the wards which will be inundated, those wards and localities, depending upon the depth of the water, are being identified and the warnings are being issued on day-to-day basis. Last but not least is our services for you can say design storm analysis for you can say reservoirs safety and reservoirs construction, where IMD is the only agency, nodal agency in the country to provide analysis, operational forecast or operational you can say service for providing return period analysis as well as the maximum probable precipitation. We call it PMP, the highest possible rainfall that can occur in a particular area, project area. This service is IMD is providing by analysis by various GIS-based techniques and all projects which are likely to be developed by any private or government agency, they depend upon IMD's forecast of how much maximum rainfall over a particular area can occur over that particular project area, so that they can design the spillway and other capacities of that project area or dam area, reservoir area. So this is the service which IMD is providing, sir. And this is my last slide, Professor Gosai. As you have already presented in your presentation, the next 5 days we are able to provide how much water level will rise and how much in different river basins and decrease. But we have to go beyond 5 days. There is a demand for to provide information in at least next 1 to 2 weeks. And here IMD is again working with the research institutes in India as well as in the US and WMO, where under the project which we call Hydro SOS, the current status of water and the change in the level of water in different river sub-basins next 1 to 2 weeks. And we are taking Ganga, Brahmaputra, Meghna, these 3 river basins we have taken on the project basis, pilot basis, where we will be generating forecast in not only 5 days, but 10 to 15 days in advance, how much the water level will increase or decrease in these 3 river basins. So this is the project work which we have taken, sir, on pilot basis. Hopeful to complete it next 2 to 3 years and then provide this service operationally to the country, to the various agencies. With this, I conclude my presentation. Thank you.
Thank you. Thank you much, Mr. Yadav, for sharing with the audience here the range of products and the services which IMD is offering now. And I think we must congratulate IMD to just have this overcome over the last decade or so. There's a lot of progress which has been made by IMD in this regard. Just to break the autonomy, I think we'll take over the last presentations, maybe 2 or 3 questions, so that we are not finding people getting bored. If there are some questions you want to put to the presenters who have presented so far. Otherwise, we'll continue. Any specific question anybody has? Yes, Doctor.
Real data. So do these models then internalize that as using new technologies?
I think Mr. Yadav will be a better person to really find out from him that when they, is there a process in place where you are comparing the validity of your forecast, how good the forecast was when you are comparing with we are doing at our end to a certain extent, but it varies from place to place.
Is it manual or is it also using artificial intelligence kind of methods to already internalize?
Let's hear from Mr. Yadav. Mr. Yadav, do you have any procedure to really validate your forecasts in an automatic manner using some artificial intelligence or some other tools?
This is regarding verification and validation of the forecast. You are aware that we cannot improve our forecast unless we know how much accurate it is. And therefore, there are, you can say, softwares developed for verifying each and every forecast. Now, the government demands, every year, the government itself demands our accuracy and how much it has improved and deteriorated. So each and every forecast, for rainfall, temperature, river basin, flash flood, We are
For the-
generating our verification scores. And
For the rainfall, can you tell the audience what is the level of accuracy which you have found out?
Rainfall, as I told in my presentation, we are making a forecast from day 1 to day 5 operationally to the public, and the accuracy for day 1 forecast is about 74%.
That's very good.
Accuracy for day 1 is 74%, and as we go to day 5, it reduces to about 60%. So
Okay.
this is the level of accuracy for rainfall forecast.
Now that is a reasonably good accuracy, because if you can get 75% accuracy for day 1 also, that gives you a good, very appreciable lead time. Thank you. Any other question anybody has? Otherwise, we'll go over to the next presenter, who is again virtual, Ms. Shruti Deke. She's going to talk on fuzzy cognitive maps for unwrapping the complexity of risks in coastal ecological systems. Ms. Shruti, are you there? Over to you. Please make your presentation. Please take around 10 minutes to present so that we have some time for question answer.
Hello and good afternoon to everyone. I am Shreya from Vishweshwaraya National Institute of Technology, Nagpur. And today, on behalf of Shruti, I'll be presenting the research that has been done on the fuzzy cognitive maps for unwrapping the complexity of the risks in the coastal socio-ecological systems. So, as it has been discussed in the previous sessions, failure in the governance and the policies often increases with the rising uncertainties and changing dynamics and complexity in the systems, and that the policy decisions and adaptations under such complex scenarios frequently produce unsustainable outcomes and also increase the risk to the climatic phenomenon. For instance, in the case of the Mahanadi Delta in the Odisha, the hard infrastructure, the hydraulic infrastructures built for the flood defense disrupted the natural linkages between the wetlands and water, which further aggravated the vulnerability to flooding. So, as such, in a complex world where everything is interrelated, the actions that are aimed at certain factors often have repercussions on the other interrelated factors. So these repercussions can change over time, and they are highly uncertain, and they keep on fluctuating. And then there is increase in the overall vulnerability of that system to the disasters. So we attempted to model this socio-ecological systems of the 7 coastal settlements from East Godavari region of Andhra Pradesh, and the coastal settlements being a highly sensitive and complex in nature, and at the same time highly vulnerable to the effects of climate change and the resultant disasters. So we built the research on the understanding that the changes in certain components of this system will have multiple indirect effects on the whole system, which could disrupt the system's functioning, and consequently, under the circumstances of rapidly changing components, there might be a deviation in the desired state of the system. So with this understanding, we critically examined the preferred state metrics for achieving disaster resilience in that system. So at first, we explored the impact of disaster risk governance policies on various components, and then what happens to policy implementation if there's a variation in the key components. So the case study area is located in Andhra Pradesh state of India in the Godavari estuarine region, which is the second largest estuarine region in India, and the ecosystem supports diverse local fisheries, which constitute a significant source of income for traditional and deprived communities. So 7 settlements from the Gautami Godavari estuary region, as indicated on the map, were selected. So the past decade, this region is noted to be one of the most disaster affected areas, and the selected settlements were the ones that have been declared most vulnerable to cyclones, storm surges and floods. For the selection of 7 settlements, the factors such as the distance from the coast, the vulnerability of the settlements, remoteness, access to the basic resources were also taken into consideration. Now, the fuzzy cognitive map which is a type of recurrent neural networks with aspects of fuzzy logic, were used for mapping the system and its processes with the help of key concepts and causal relationships for understanding the coastal rural socio-ecological system of the case study area. And the limitations pertaining to temporal issues and the non-linearity in the relationships of the stakeholders were then addressed by validating the results of the model with the stakeholder knowledge and experiences. So the integrated dynamics of the study area were modeled with the help of the mental modeler software. So deriving the components of the system was again another challenge. So only the frequently fluctuating components which have a significant impact were selected based on the literature, focused group discussions, cognitive maps, community consultations, and inputs from the experts, and were divided into the basic cultural, socio-economic, ecological, physical infrastructure, and then anthropogenic activities, hydrometeorological hazards, and governance, just for the ease of display. And the interrelations between these components were represented as nodes or concepts, generally as a reflection of the qualitative characteristics of the system, say between 0 and 1, in a way that their combination, interaction, and functioning determine the characteristics of that coastal rural socio-ecological system of the case study area. The correlation between the two variables was established based on how they are related, and the coding between them was set to 0 and 1, or -1 and +1. So graphical mental models were then gathered from 181 participants of the 7 settlements. The sample included a combination of fishermen households, population dependent on the mangrove ecosystems, and so on. So the study considered 63 nodes or concepts and 93 causal relationships among these concepts, as shown in the previous slide. And they were formulated based on the semi-structures. There were multiple semi-structured interviews based on the prior discussions and reconnaissance. So this first diagram, this final diagram was prepared using the mental modeler, where the thickness indicates the strength of the relationship amongst the components. That means higher the thickness, higher the weight of the relation among the components. And the positive edges of every key concepts were represented by blue color, and the negatives were shown by red. The degree of significance of every key component was recorded based on the resident perception. So the cognitive maps represent community experience of previous cyclones, or present sea level rise, and climatic extremities. So these mental models graphically portrayed the perceived cause and effect relationships of the human nature interactions, and the 7 mental models from the villages were individually collected and then combined using the single level aggregation. So this figure here represents the final master model for the analysis, which was used as an input for the software. So scenario analysis was then used for analyzing the resilience pathways, when the values of one or more critical components in the model are changed to create a what if scenario, representing the dynamic behavior of the fuzzy cognitive maps that contribute to the resilience in the system. So the variations in the system state are then recorded with respect to the steady state. The higher values indicate the importance of all concepts or the individual weights of the concepts in the overall model. Then these concepts were selected based on the convergence of both higher centrality scores as well as the significance indicated through the participant perception. So these were the concepts that were found to have significant impact on the rural, social, coastal, ecological systems of the case study area. It was observed that saltwater inundation, being a key risk in the coastal areas, affects 20 components. So the temporal influence of saltwater inundation on various components creates 2 possibilities, considering the factor of time for which the saltwater inundation occurs, say the projection of saltwater inundation or the depth of water increasing with time. So other one is the increasing time duration of saltwater inundation. So the scenario A is important in context of storm surges as the people at risk increase with the increasing depth of the surge, and the other one is about the duration when the salt water stays on the land, which is further linked with multiple other components and finds more relevance with disaster risk assessment. Again, the component-wise examination of the influence of saltwater inundation for different time durations was examined. It was found that aquaculture is highly sensitive to saltwater inundation, but it is important to note that saltwater inundation has varying impacts for different durations of time. So 25 components were found either increasing or decreasing. So other scenario was related to the governance. Like implementation of 100% implementation of the governance strategies, say by increasing the parameters relating to vocational training, ecosystem conservation, participatory governance, early warning systems, ecosystem knowledge, and increased training of evacuation, risk transfer, and ecosystem based livelihoods training were found to be either increasing or decreasing. So in case of combined scenario, where upon the introduction of an increased saltwater inundation and the governance scenarios did not work as planned. So the variance here represents the probable failure percent of policies selected under the category of governance. So agricultural productivity, drinking water supply, surface water quality, and aquaculture have higher variability compared to the other components under the influence of saltwater inundation in the presence of effective implementation of governance components. So more than 100% variance indicates higher chances of failures of policies, and 50 to 99% indicate the medium chances of failure, and 1 to 49% indicate low chances of failures. So therefore it gives the idea that these components should be given prior importance during the planning for disaster risk reduction. So this takes us to the conclusion that despite the existing illiteracy in the region and the remoteness of that region and the technological and economic hurdles in that region, the fuzzy cognitive mapping method proves to be an effective solution for accumulating all the previous experiences as well as the present knowledge of the local communities regarding the socio-ecological systems of that study area, and that the temporal dimensions of the cognitive mapping can be addressed to the community participation and accurate scientific observations. So that's it.
Thank you.
Thank you.
Thank you, ma'am
Yeah.
Ashida, for a very nice presentation. I just wanted to have a query from you that when you set up the neural network, what was the objective function used?
I'm sorry, I might not be able to
Okay,
answer this question.
no
I'll
problem.
definitely direct this question to Shruti. You, you may reach out to her
Yeah,
email
we'll
ID.
do that. I
Yeah.
thought you were also working together with her.
Yeah. No,
That's fine.
I was today just presenting on her behalf
Okay,
because she was
thank
not
you.
available.
Thank
Thank
you
you so
much in
much
any
for.
case. Thank you. So we'll move on to the next presenter, who's Mr. Anshuman. He is going to talk on climate change adaptation and agricultural water security. Mr. Anshuman is the Associate Director in Water Resources Division of TERI, and they're doing a lot of good work. Over to you, Anshuman. Anshuman, 10 minutes will be okay?
I'll try to be brief, sir. Thank
Fine,
you.
please.
Thank you. I hope I'm audible. Thank you, Chair. I wanted to share our experience on the perspective of an integrated work on basically climate change modeling and impacts on water security, especially agriculture water security, and also the assessment of the watershed development in Krishna Basin. This is a work that we did in partnership with the Australian government, IWMI, University of Melbourne, and as well as IIT in Pune. The idea in this particular project was to look into what are the kind of impacts on, impact of climate change on water security, especially the agriculture water security in Krishna Basin. If you look into the perspective, this is some time back, assessment and study that we have done. Basin actually had been, seeing a lot of closure, basically because of the cumulative impact of the larger irrigation expansion activities and watershed development programs. Also on the increasing number of tube wells, basically increasing the groundwater irrigated area as compared to the surface water irrigated area. The mean annual runoff basically decreased over a period of time, and there was a significant decrease observed. Basin is said to be more than 80% closed to the stream flow that was observed in the period. And number of other challenges, especially what was assessed as well was the continued watershed development programs and the irrigation projects roughly doubled the demand, and also the basin closure basically resulted in the continued inter and intra-state conflicts. Besides other challenges of, let's say pollution from the cities as well as, let's say inaccurate allocation of water for environmental ecosystem. So there was a need for adaptive planning and demand management is what we actually, put forth for consideration in this particular project. The approach was to look into the hydrological regime and climate change in the basin and assess the impact on the watershed interventions. Also to develop a framework. Something that we approached in this particular project was basically connecting with the different tiers of stakeholder in the basin to basically come across with identified and prioritized, stakeholder-derived, stakeholder-defined adaptation scenarios clubbed together with the scientific information that we've had. And also to look into what are the kind of, hydroeconomics of those interventions to take forward for recommendation for the particular region. And I want to mention about a particular approach of scenario planning in this particular project that the consortium looked into. Basically, this is an approach where we, have a more let's say flexible and adaptive, decision-making taken into account with no regret options when the consequences are really severe and the uncertainties are very high. If the consequences are low or the uncertainties are high, you can go with the, deterministic planning and BAU kind of decision-making. But when the consequences are very high and the uncertainties, as in most of our models are actually a bit high, then it's often, helpful to look into scenario planning approach. Something that we used in this particular project. Now, I'm not going to go into detail of, the entire climate, regime, climate modeling regime, but I just wanted to give you a perspective that we looked into a very integrated planning and management approach where we did the modeling, from GCM to RCMs, assess the demand, looked into the hydrological impact assessments, as well as stakeholder defined adaptation options that came across, looked into the economics of it, and then through scenario planning approach came across with what could be the adaptation strategies. So I will just be very briefly sharing with you the kind of findings and the outputs. Now, rise in temperature, reduction in rainfall has been known in this particular region for some time. Our models as well, kind of predicted that so we did, 3 time slices of 30 years in models. And what we found out was in the initial, well, there is a lot of variability as well, but then to put in perspective the overall findings, the first time slice showed for the Himayat Sagar and Osman Sagar stream flows an increase of around 24 to 14%, but this actually showed an increase in the later period time period. But then this reservoir inflow reduction has been observed for some time, and this was an impact which was assessed as well, one of the major impacts in the region. Now, we looked into, what we did was we went to the different stakeholders at different tiers. So the central state government agencies, district level authorities, and the, farmer level and civil society and village level, communities to apprise them with the kind of findings and impact that we assessed, and also engaging with them through a very organized process on finding what are the kind of interventions that they would see as prioritized adaptation options. So a whole series of process of consultation, finding a shortlisting of the preliminary options, kind of further ranking of the options and prioritization is what we did at different tiers, not only at the grassroots level but also at the state and district and community level as well in this particular project. Based on which I'm very putting it in a very summarized way, and this is a very extensive work, both modeling and stakeholder engagement. Based on this, we came out with different tier prioritized stakeholder adaptation options, as you can see in this particular slide. A range of options were considered, right from diversification of livelihoods, changing cropping pattern, water allocation, increasing the participation, farm pond and tanks to be constructed, and so on and so forth, improving the efficiency of water management. Amongst all of these, the ones that we identified as the prioritized most prioritized was changing cropping patterns, increasing watershed development, and improving irrigation efficiency. Now, all of these do make sense, immense sense, in basically moving towards water security. But a good question was to look into what would be the economic impact of, the interventions once it is taken into account at the level where we are, talking about, for the policymakers. And the economic models of the project actually looked into this perspective. And what we found was, I'm again summarizing this, there was a lot of iterations that happened amongst all of the options. But basically that implementing a crop diversification policy would appear to have a greatest return in the context. Watershed development and efficiency improvement, they did have value, but then over a period of time, they had a lower, value, as compared to the currently experienced value. Also, the recommendation that we put forth was that the potential policy intervention should have, evaluated both for its water security and economic outcomes at a catchment scale, not just the, technical assessments only. So what is optimal, for example, and ideal from physical perspective at one location that necessarily may not provide the best economic outcome is what we wanted to convey as well. And also, as I said earlier, in response to climate change, the focus on no regret and flexible adaptive options and approaches over the less flexible options would make much more sense. As in this case, we found out for crop diversification over the watershed development and irrigation efficiency. Now, one of the things that Professor Gosai as well has mentioned is, watershed development activities, especially in the upper reach of the basin, actually had an impact on the surface irrigation water availability. And that had actually, created a risk or sort of, decreased water availability, something that, came into play when we assessed and evaluated this particular set of intervention. The perspective also about the climate change strategies, they need to be designed keeping in view of the individual catchments and whole of basin perspective, and must be aligned with political structure and stakeholder interest through a multi-tier consultation, something that we focused on in this particular project. Also, regular assessment, for dynamic allocation of water is possibly very, very important perspective. I don't know how much it is happening right now, but I think this is very important. Possibly it should be institutionalized as well. Transparency in data sharing, flexible and adaptive approach should be taken up. I think this is something that I have emphasized along with the stakeholder consultative approach. So that's a very summarized way of, this particular project that we wanted to share. I think, in the perspective, I would also like to share with you some of our work on actual implementation of some of these interventions suggested. For example, in the perspective of water conservation, similar approach of using models based, identification of the interventions, water balance, in a particular region assessed and identified, prioritized and identified intervention for that particular region. In this particular case, for example, in southern Bangalore, what we found out was that the subsurface intervention would make much better sense. And we went ahead for, groundwater recharge intervention. And not only modeled and designed, but we actually implemented along with the engagement of the local stakeholders, around 6-7 structures in that particular region, amounting to be about, around 70 million liter per year of, capacity through those structures. Besides other interventions as well on rooftop rainwater harvesting, agri-water interventions, farm ponds, etc. We just recently finished one more project on basically, rejuvenation of ponds in Punjab region, where in total, basically, those areas which were more of a sort of filthy kind of, dumping sites for solid waste and, wastewater, we tried to convert them into a rejuvenated pond, which could recharge the groundwater as well as make the water available for irrigation. And the last one that I shared a bit in more detail yesterday, but just to quickly reference this, basically this is a project on direct benefit transfer through electricity of agriculture. Basically in this one, what we did was we again engaged the stakeholder farmers in the Punjab region to demonstrate to them what are the kind of interventions which are best suited and will give you a good return on both not only crop productivity but also saving water and energy. Let them choose what they want to implement in their farms, and we created a demo and control farm basis and monitored the kind of outputs from both of those interventions. And what we could find was a range from around, let's say, 60 to 30% was what we saw in terms of saving of water and energy. So I'll stop here, and if there are any questions, I'll be happy to take them later. Thank you.
Thank you, Anshuman. Thank you for sharing your some of the projects which you have concluded and the outcome of those projects. I think all these showcased case studies are very important because most of the time people don't believe in you. So if you create something which is creating evidence in turn, then even the stakeholders will be also be willing to participate. We'll move on to the last presentation by to be made by Dr. Mikhail Milovic. He's a research scholar in IIASA water program, and he's going to talk on the topic refining the human influence within the water cycle model CWATM demonstrated at hyper resolution for the Bhima Basin. Over to you, Dr. Mikhail.
Good afternoon, namaskar, guten tag. The stage has been well set already by the previous speakers, so thank you for the opportunity to go last. I'll be discussing, basically, as Professor Gozain said, to understand the system. This is, I'll be discussing the hydrologic model CWAT-M. SWAT is another hydrologic model. This is part of a larger project called FUSE that embeds different human decision models inside the hydrologic model. I think of the hydrologic model as the stage that we can test different policies and experiment different things on. So the water cycle is the movement, transformation, flow of the water cycle, of water on Earth. What we're looking at is the Bhima Basin, and we were set up again. This is the upstream part of the Krishna Basin. Slightly different than SWAT, which uses hydrologic response units. This is a grid-based hydrologic model. You see the little yellow square. This is one grid. We'll come back to this later. So just so we see where we are. Let's see if this... All right, this was to zoom out to show us where we are in the Bhima Basin. But just to show you, so all of these little circles are little cells, and water passes from one cell to the next cell. Each cell experiences the whole water cycle. The Bhima Basin is definitely interesting.
Shared it on your website so people virtually.
Please. Hello. I'll begin from here. So just discuss briefly the area and the water cycle we're dealing with. Rainfall is there is no upstream river. Rainfall is concentrated towards the west and only through 5 months of the monsoon. So the interesting thing is to deliver this water throughout the entire year and throughout the entire basin. Evapotranspiration, illustrated in darker green as more evapotranspiration, is really concentrated over irrigated agriculture, but also within the Western Ghats and also over grasslands. You see the dark green areas. These are really the command areas within the Bhima Basin. What we're looking at here is sort of a water balance circle. So the precipitation is balanced. This is an average. We're looking at 2013, but this is sort of average for every year in the Bhima Basin. 70% evapotranspiration, about 20% river discharge, and then other things like river evaporation, lake evaporation. We come into these a bit later, but to know that precipitation, evapotranspiration, and downstream discharge are the main flows within our system. This is it. Throughout an example year, we have rainfall as this sort of sharp pulse just during the monsoon, and evapotranspiration, a smooth, elongated outflow through the system throughout the year. So one way that we validate and calibrate hydrologic models is using discharge, as was discussed previously, but we can also pair with just generally creating this water cycle diagram through different sources of data. So here's an example for the year 2002. We see evapotranspiration is about 27 kilometer cube. Rainfall is quite similar, and then the difference between storage change, surface water, and groundwater flips between the years. When previously we were discussing discharge as the main calibration point, we have calibrated this model to groundwater levels, that's fluctuations and depths, reservoirs, which I'll discuss a little bit later, and these data circles. So this is C1M. You can't see the little cell in there, but so every cell can experience the whole water cycle. So we have water going through the soil, groundwater. We've coupled C1M with the groundwater flow model, ModFlow. C1M is also open source and developed in Python. One of the motivations for creating C1M was to make it really a community developed model. There are tutorials on YouTube. The idea is that this can be applied, let's not say easily, but with interest, one can apply this to any region in the world and well connect with other models is the idea. So we allow for different abstractions through river, lake, reservoir, groundwater, both delivered and local. So you see here is an example of the Bhima Basin. The darker blue represents areas of a higher abstraction. You can't see my cursor, but if you look towards the top, you'll say Pune in dark blue towards the top left. So this distribution of groundwater and surface water, rivers, lakes, and reservoirs, how it's distributed towards irrigation, domestic, industrial, and livestock is also included within the model, although industrial, domestic are exogenous, but in this case come from human decision models. We have one thing I want to discuss is that the Bhima Basin has one of the highest densities of reservoirs in the whole world. In here, we include 47 different reservoirs. What we're looking at here are all the reservoirs and lakes. This serpentine figure in the middle is the Ujjaini Basin. Reservoirs are terribly interesting to model as they are operated daily by following guidelines, but also related to downstream demands, upstream capacity, current and projected rainfall, operator experience, and then informal agreements, whatever that might mean. So the interest was to find a sort of pattern. The interest is to project into the future. This is to say, we've been discussing early forecast systems or early warning systems. The motivation for this model is, in a sense, early warning, but not for flooding, for projecting into the future, 2050, 2040, beyond, to see how different policies and interventions might affect or challenge or support the Bhima Basin during periods of flood, periods of drought, and then just normal years when they can sort of benefit from the system. The font's a bit small, must have changed in here, my apologies. But the idea was to find a pattern in reservoir releases as reservoirs dominate the distribution of water within the system. So using reservoir data on daily irrigation releases and daily volume. You see on the right, the top, both of these are the same graph. The top one is just isolating 4 of these. This shows the irrigation releases within an example year. One doesn't see a pattern. Again, irrigation releases, reservoir releases depend on many different inputs to decide on how this happens. But interestingly, we do find a pattern when we take the relationship between releases to volume. The top figure shows this ratio for all the years. You can already see the pattern coming out here. And the bottom one shows the median and the mean of this relationship. So using this, I give the example of 3 different reservoirs. We use this bottom curve to say how much water is released depending on the volume that is in the reservoir each year. This allows us to both go into history to see how it relates to observations and then project into the future. So using this method, we have, I show 3 different magnitudes of reservoirs. You have the huge Ujjayi, which is in the top graph illustrated with a bit of orange. Then you have Dimbe, which is also the photo on the right relates to Dimbe, I guess more red. And then the bottom squiggly line that looks like a flat line related to Ujjayi is Kharakvasla, which is the main reservoir or the pickup reservoir feeding water to Pune. Using this sort of simple method of determining a release curve, we see incredible matches with reservoir volumes observations throughout history. So using this, we can have some confidence in how reservoirs distributing water throughout the Bhima Basin affect water within the Bhima Basin. The last major part of this, there's about 40 to 30%. We have done a coupling with mod flow, which allows for lateral flow throughout the basin. It's been said before, but in fact, I think the people who work with energy talk of having rich data, and water is always data sparse. But I would say we have had rich amounts of data, both rainfall, discharge, and as you saw for reservoir volumes. So we're using about 380 groundwater observations. It was part of the calibration of this model as well. This is taking the average water table fluctuations across all the years with available data with a relatively good match. When it comes to individual wells, I just isolate 4 of them here. The depth can be corrected, but the general fluctuations of the water table are matching relatively well for us to determine how water comes from either surface water or groundwater. And then, of course, as has been said, the interactions between them when rivers add to groundwater, when groundwaters add to rivers. So my last slide, simply to say that this hydrologic model, which is again the stage with the other human decision models connecting into it, allows us to safely experiment with the Bhima Basin. Early warning system, not necessarily for flooding, but for determining how different policies might affect floods, multi-year droughts, and then normal conditions into the future. Yeah, thank you for the opportunity to be here.
Thank you, Dr. Mikhil. Very interesting presentation, I think, is this is the kind of perspective which is needed to be known for respective land masses in the form of river basins. And that's what we have been saying, that it has to be informed decision making which will make the difference. So now we'll open the stage to any questions anybody has. Yes, please go ahead. You can take the mic, I think, that'll be better. And you can also give your name so that if they are doing some recording, it could be recorded.
Hi, this is Shanko Ghosh from the Celestial Earth. So the data that you showed, I think it's from 2007, right? After that, there has been a lot of drying up of these reservoirs, and probably primarily due to sugarcane and cotton production. And this has like I was living in Pune in 2016, so it was completely dry, and people used to get maybe an hour or 2 of water supply. So how do you consider those into account?
Hello. Yeah, I was just using an example here, but the model is running until 2020, and then we project to 2050. But exactly in these cases of drying or multi-year droughts, we also the question is, what are initiatives that could somehow allow for less detrimental effects? Increased tanker market obviously came up in this situation and also is projected into the future. There are 5 Tata reservoirs within the Bhima Basin that divert water from the Bhima Basin over the Western Ghats towards the west to produce hydroelectric power. So one question that very much comes up, or one thing I didn't mention, is that very much like your project, we've been involved in several different living labs or workshops within Pune. We just had one several weeks ago to determine what would be the initiatives that could be the most interesting to test. In these multi-year droughts we project in the future, the Tata dams are also quite dry. So this also doesn't come up as an opportunity. Groundwater within single-year droughts is the most awesome buffer, let's say. This part of India doesn't have huge storage. The groundwater fills up and is abstracted generally each year, but the storage is significant enough for at least a 2-year drought. We see that after 3 years of drought, that even the groundwater is not sufficient, and then tankers or groundwater from very much outside Pune comes in to supplement the water. But I guess the real thing is you brought up sugarcane in this area is significant, and it's also been discussed today that crop choices, even before this drought happens, moving away perhaps to less water-intense crops is the more systemic or sustainable solution.
Yeah, like the nexus is pretty apparent now, because there was like in Punjab, if you look at, there was a sudden increase in agricultural pump because of subsidies. Now, because of that, the sale of pumps grew in a lot during this 2015-16, and now the water table has gone down a lot.
That's exactly the point, that we need to have policies which are not going in the wrong direction, and that needs a scientific backup.
Nexus kind of.
The nexus has to be broken with the information. You have to put the information in the public domain, and that's the only way you can survive as a country, because otherwise, if you don't use the proper decision making, then you are going to create a lot of conflicts. There'll be conflicts between the villages, there'll be conflicts between the districts, and then maybe going to the state level and within the different states also. That is already happening. I think every state is having some kind of the case done on the adjoining state, and that is very scary. So I think we need to really come out with the information so that everybody understands. And then, being a democracy, you can put the societal pressure. That's the only way I think it can work. So any other question?
I have a question.
Yes, please.
Thank you for the presentation. My name is Gagan from Systemap. I have a question about the model itself, C-WAT-M. How do cells perform in an urban context? And just to stack it, do you consider population projections into the mix? Thank you.
So in the urban context, at least hydrologically, water still passes from one cell to the other. There is only urban runoff, so there's less soil percolation and groundwater recharge. Yeah, there also this model is combined with a sleuth model, which is for the growth of a city. So we have urban growth of Pune and Pimpri-Chinchwad and Solapur up until 2100. And then again, using with this projections of population and GDP. Within Pune itself, there were 2,000 surveys done to determine how people use water under different contexts. So this is the human decision model within Pune, how people use water in different contexts and at different prices is not what was presented here, but included in the general model.
See, in these models, the scale is a very important thing. Which scale you are at? Are you at the urban level where you are looking at the city per se? Then your total complexion changes. And you have to see that what will happen to the water which is flowing within the city, and what are the sources, what is the interaction. Good. Any other question anybody has? Otherwise, we'll wind up this session, and let me thank all the presenters. for making very nice presentations, and even those who have made the presentation in a virtual mode. Thank you very much. To the organizers, if there are any messages or any
No, sir.
announcements to be made.
Yes. So finally, as we end this session, session 8, thank you everyone, to the speakers who has joined virtually, to the honorable speakers being present here. Before we part away, I would request our chair to felicitate our speakers with a token of appreciation. So starting with Dr. Anshuman first. Thank you, sir, for being with us. Mikhail. Thank you so much, Mikhail, for being here. So I would request Dr. Ritu Mathur to please felicitate the chair on behalf of TIFAC and IIASA. Thank you so much, sir, for moderating the session so well. Thank you, ma'am, for being with us. So we'll assemble for the lunch. The session is already delayed. We'll assemble here back at 2:45, 15 minutes short of the allotted period. So the next session would start at 2:45 IST. It's automatic.
Thank you. It was a follow-up after you.
Thank you. Very nice presentation. How many people are there in water?
Oh.
Good afternoon, organizers.
All of the speakers are requested to please on the dais. Ajay Krishna, Dr. Kaveri. So introducing to the chair, to all the speakers who are present here virtually, Dr. Ritu Mathur is presently a senior energy consultant at NITI Aayog. She's been working in the fields of sustainable development, energy security mitigation, and climate change for around 3 decades. I hold over the session to you, ma'am.
Yeah, so good afternoon. And I think we've heard a lot over the last 2 days and the sessions this morning. And this session is focusing on the human dimensions of transition to sustainability in the energy sector. I think among all the challenges that also Rangan mentioned in the plenary just a while ago, while there are these infrastructure related, finance related, and the entire gamut of what to choose, I think thing which is most important, which we also heard in one of the morning sessions, is also about people. Because it's finally people who will get impacted. It is people who will have to face the brunt of the challenge, and therefore managing the transition in a way that people are taken along in terms of their livelihoods, in terms of being able to afford the changes, and that, you know, it's a smooth phase over is one of the most important things. So I do have a few slides, and I will run through that to just sort of also set the stage in terms of the need to look at the social economic side of the transitions. So just if you can get to the next slide. It's too small, but it's okay. Yeah, so I mean, I won't go into the details of all the numbers, but just to set the background, and much has been said about it already. Being in India, we do have still a lot of challenges. We heard things about having low per capita energy and still being very low in terms of our own emissions. So there's, of course, the whole discussion about where we sit in terms of the carbon space. But when we start looking at what people have in terms of the access to clean energy sources or infrastructure or services, we still have way to go in terms of the need for improving our access to electricity, our access to other energy forms. Next slide, please. Again, looking at it globally in terms of access to clean cooking, while we have made progress, but again, what are the kind of solutions that we have available, and how we can get people to have access to enough affordable fuel for all their needs is again a big challenge, which still needs to be fully met. Next slide. In terms of per capita primary energy consumption, again, India is one of the lowest in terms of the color shading that you can see there as well. And I think we need to keep India's Human Development Index and the need for development as a key priority. And since this needs to be a center stage, there, according to me, is no way that we can compromise on any of these developmental challenges that we already have. Next slide. So in terms of, again, the carbon space, like I mentioned, we've used only a very small amount of the carbon space if we look at historical emissions. Having said that, the country has also taken on a great leadership role in doing enough in terms of what it has spelt out as its targets during the Paris Agreement, and it's moving in line with its commitments. Next slide. And also more recently, we have at the COP26 taken on even more ambitious targets, and just a couple of days ago also updated our NDCs in terms of becoming even more stringent in terms of the emission intensity requirements and in terms of the levels of electrification capacity, which is non-fossil. So again, the country is geared towards, and of course, we have the target goal of becoming carbon neutral by 2070. So these, are two very different kinds of things where on the one hand, we are saying we need to develop and grow. And this, of course, is a priority. But at the same time, we also need to decarbonize and move towards a net zero pathway. So, of course, we also heard Rangan talk about just now in the plenary in terms of there could be many uncertainties, there could be many pathways and many options. What we pick and choose will need to be seen along the way. But if I just put up an illustrative net zero trajectory, which we've again worked out through the ISS tool at Niti Aayog, you can at least get a picturization of how coal would need to sort of start transitioning downwards. Oil and gas and the other fossil fuels need to start declining in terms of their use, and how the renewables and biomass will need to start growing, taking on a larger share. So even in terms of percentage, this seems to nearly sort of reverse, moving from the current percentage to having about 80% odd sort of based on renewables or non-fossils. So it's a very, very large transformative change that we are looking at within the energy system, which would be required by 2070. Next slide. And therefore, this also makes it very important to look deeper, not only in terms of what would be the choices of fuels that we use, but also starting to look at the spatial implications of energy transformation. So as we know, like the coal and coal resources are sort of concentrated in the eastern and central parts of the country. And those are, some of those states are also the most vulnerable when it comes to the poverty, etc., in those regions. So looking at what the impacts of transitions will be if we move away from fossil fuels and the livelihoods which are revolving around fossil fuels in those states. Again, there's a mapping which shows the distribution of multidimensional poverty, and you would see a lot of those regions are also around the regions where we are likely to have the shift away from fossil fuels towards renewable energy sources. Next slide. In terms of the impacts on the workforce, again, clean energy transition is estimated to impact about 21.5 million people, according to one estimate, who are working in the fossil fuel and fossil fuel dependent sectors of the country. And many of the people in this workforce are also involved informally. So, I mean, they don't get counted, and they might also face the worst impacts when it comes to the implications. Also, the sectors, if we look at where there might be large impacts of energy transition, include, apart from coal mining, the steel, cement, and automobile parts kind of industries, which could have large implications in terms of finding alternative livelihoods for these people. So the point about reskilling, the point about having vocational courses, the points about, do these people have the requisite background to be able to take them to another livelihood? All of those become very meaningful and very important as well. Next slide. If we look at the revenue implications of energy transition, again, the coal, oil, and gas together contribute about 18% or so of the total revenue receipts of the central government, about 8.3% of the revenue receipts of the state governments. So again, as we move away from the fossil fuels, what are going to be the revenue streams is also something which becomes important to consider and think about from a financial point of view for the country. So again, I think there is a need, therefore, to look at alternative routes through which revenue generation will need to be looked at going ahead in the future. Next slide. And therefore, again, the need for a system-wide focus for a successful transition becomes very important. What we have been doing is going to transform into a very different kind of way forward in the energy transition itself. But that also means that we have to be able to envisage structural changes also in line with our socio-economic and development side of the story. There are some programs like Make in India, skill development, and other training programs. But I think, again, a systemic kind of a view to look at what to do, where, who to take towards what kind of shift and so on would be required even more. Also, we need to identify and promote activities which would enhance the opportunities for growth at the countrywide level. probably enable various social groups to connect with and enhance the adoption of emerging opportunities and best practices. Also, we would definitely need to transform the challenges to opportunities for India by improving the resilience of the economy and also of society, by managing the transitions in the short, medium, and long term. And definitely we would need to intertwine the development planning with the energy transition planning to make all of this successful. Next slide. So as I said, it's extremely important to connect the economic and societal development with energy transition. And therefore, we do need to position social justice and equality within the societal transformations as we go along. So again, local knowledge and global best practices both will need to be brought together in going forward. We will have to have greater connects with regional considerations in the economy. We would have to invest in human development and social infrastructure, and of course need to scale up at the economy level to create jobs, enhance growth. And therefore, strategically, we will have to also look at alternative economic growth models to examine what kind of opportunities India can have going forward in trade, in moving away from what we sort of move across borders today and in the future, and where we could have opportunities again, and also having to make our growth inclusive to address the challenges of inequality. Next slide. So as we move towards transition, we'll have to ensure that the transition, of course, is just, and this is just a diagrammatic representation of the elements which we will have to keep in mind in ensuring that we go towards a just transition as we move along. Next slide. So again, what needs to change, I think, has been studied to quite an extent. But how to make the progress is where I think we need to now start looking at deeper in terms of making systemic changes, but also looking at things in a holistic manner as we move towards a net zero emissions energy system, and keep in mind how to transition in the short, medium, and long term such that we do this in a way that is sustainable. So with that, I'll end my brief talk and move on to the other speakers in the panel. If there are any burning questions, we could spend a minute, but otherwise I'll just move on. Yeah, yes. How can we become safe? Okay. Would you want to speak into the mic for people who are in the online mode?
Do we have any options for becoming more safely nuclear and kind of offshore nuclear?
Yeah, so again, from what I know briefly, nuclear again has been moving forward in terms of the technologies that are coming up. So the small and medium-sized modular reactors are sort of becoming more viable and safer. So those are probably also going to be important elements, especially I think what Rangan mentioned in the keynote speech as well earlier. I think we'll have to have all kinds of bullets, of course, in our basket, and there are uncertainties. But when we look at renewable, which is one of the biggest things in the basket, to some extent we can do things. But after that point, the level of intermittency needs to be handled by other options, even when it comes to electricity. So, sorry? Seasonality and yeah, to that as well. And therefore, I think nuclear will have to play a stronger role. And how much we do, where we do, with what technologies we'll do, will need to evolve as we go around. But definitely, I think it is an important thing in the basket. Any other questions? Okay, so let me then move on to our next speaker, Dr. Edward Byers, who is joining us virtually. Dr. Byers is a research scientist with interest in infrastructure systems, climate change risks, and development economics, with a range of multidisciplinary experiences in working in the academic, intergovernmental, nonprofit, and private sector projects. He is joining us online. And we are just setting up his presentation. So Dr. Byers, the floor is yours.
Thanks. Good afternoon. Hope you can see the slides correctly. Many thanks, Dr. Matu, for the invitation and for chairing this interesting session. And sorry not to join everyone else in the conference center this afternoon, but I've heard great reports coming in there from colleagues at IIASA and interested in the rest of the discussions, the rest of the day today. So I work in the Energy, Climate, Environment program at IIASA, and today I want to talk about, obviously, focus of this session being primarily energy, but how it can help in providing what we call decent living services, and also particular interest of mine in reducing vulnerabilities and climate risks, so covering both mitigation and adaptation. On the climate impact side, as we know and increasingly reported, huge numbers of people facing intensifying climate impacts, and these are hitting people across a multitude of sectors from different and also related to different hazards. On work that we had done previously at IIASA, we estimate that in a 2-degree scenario, approximately half the global population exposed to large increases in exposure to heat stress, cooling demand, changes in the water cycle relating to water stress, but also variability, more floods, droughts, seasonality, and interannual variability. Land sector also, although less people living in rural areas, huge proportions of our land area will be exposed to crop yield reductions, but also degradation of our natural environment and excessive fertilizer pollution as we try to feed more mouths from increasingly degraded soils. And we also see that mitigation has a big role to play in reducing or increasing these risks. And so the number of people exposed to multiple climate impacts approximately halves or doubles, depending on if we are successful in mitigating to 1.5 degrees, or perhaps something more along the lines of current policies taking us to 3 degrees. On the mitigation side, we've just seen the latest IPCC report come out in 2022 from the Working Group 3, came out in April. And there's a mixture of good and bad news. I think we know the mitigation challenge is extreme. And on the one hand, though, it sometimes looks like we're going a little bit in the wrong direction. Coal consumption continues to rise in the past 5 years. In the context of Asia and this session, we see that 75% of planned and in-construction coal plants are in Asia. This is possibly to be expected because also a vast majority of the world's population is in Asia, and more than half of this electricity coming from coal. Coal expansion in Asia continues, although has been slowing. And interestingly noted, I saw in the report, is though this is not really driven by mitigation concerns, but more by the other co-benefits of let's say, of not having so much coal related to air pollution and air quality, health impacts, too much capacity due to, let's say, less slowing of GDP growth, obviously more renewables and rural electrification, a little bit more decentralized energy systems, and also international financing constraints, both private and public sector financing organizations deciding that they think the transition risk of investing in coal is too much for them. On the renewable side, wind and solar growing rapidly, costs falling much faster than expected. This was a big highlight from the IPCC report, and also expansion happening faster than also expected. And particularly, this is interesting that Asia now is installing more renewables capacity than Europe has been for the first time. And we see that Asia's global share of wind and solar capacity in terms of installations is 40 and 56%. And 30% of overall electricity in Asia is coming from clean power. The IPCC scenarios, or scenarios presented within the IPCC report, however, projects that if we are to meet the 1.5 degree aspirational commitments of Paris Agreement, then we need to reduce coal use by 2050 in the order of 95%. And of that remaining 5%, that still would need to be abated by carbon capture and storage to hit net zero. Yeah. So this sees almost near elimination. This is on a global level, so this means that some regions may continue to use coal, others not. But on a global level, massive reductions, as I think really nicely introduced by the previous presentation, and in more detail. Yeah, there are considerable justice and economic implications of phasing out of coal. And although there is evidence to say that there are possibly more employment opportunities from the clean energy transition, this is different. And one of those challenges is also the distribution of those jobs, because, for example, coal production and other industries tend to be concentrated in some areas, and renewables takes a more distributed format, and actually the skill set is also a really big challenge. Lastly, coming out of the report, we know that multiple aspects, including energy efficiency, demand reduction in some aspects. We know that demand needs to increase for some people, reduction of inequalities and vulnerabilities, and accelerated progress on SDGs have really important roles to play in the mitigation challenge, but also reducing climate risk. In terms of basic access, and this has been a theme developed called Decent Living here at IIASA, which are looking at basic material prerequisites for human well-being. We can see across the world in different regions, but Central Asia, South Asia, large proportions of the population not having their, let's say, basic needs being met by within society. And a lot of these are highly dependent on clean, well, hopefully clean, but also reliable energy supply. And even the other ones are less dependent, but to varying degrees, also dependent on energy. And often the quality of these services is also improved when you have more reliable and cleaner energy. We'd like to think of this actually as a wider systems level transformation. So on the left side, we have various aspects related to climate change impacts and risks, and look towards a societal transformation across different multiple levels. And so a previous slide introduced kind of decent living, the basic services in providing things really along the lines of many of the sustainable development goals in terms of nutrition, shelter, mobility. But these need to be underpinned by wider infrastructural changes, such as energy infrastructure, transport, water and sanitation infrastructure, and so forth, which is more at a systems level transformation. More higher this or above this, I think we need to see changes in the societal fabric in our economy in terms of improving aspects such as education and governance, and these are a little less tangible but more pervasive through our socioeconomics. And ultimately, this hopefully leads us to or supports us in really climate resilient development pathways that are sustainable, include both good mitigation and adaptation policy and also just across regions and across societies. I focus now on one particular, in the remaining few slides, one particular aspect, which I think is a really nice, interesting, let's say, trade-off, or not trade-off, but actually a synergy between mitigation and adaptation, and that's relating to cooling energy and reducing the risk from heat waves. So I don't need to tell, obviously, the audience in India too much about heat waves, but we know that a huge number of people are dying each year from heat waves. And yet a very small proportion of the global population has access to simple services that can actually greatly reduce your vulnerability. And that's something like air conditioning. Yeah. And a lot of this is driven by also high inequality in our society and large proportion of the population living in slums or informal housing. And this is also increases your vulnerability to climate risks such as heat waves. They've estimated a cooling gap from the Sustainable Energy for All program in the order of just over 3 billion people in a middle to high risk category that are unable to access cooling facilities that would reduce their vulnerability to a climate impact such as heat waves. And we've been doing similar modeling work like this also in collaboration with them at IIASA. And so work published 2 or 3 years ago using a spatial model combining climate impacts information and also socioeconomics. Also estimate that, over 3.5 billion people currently unable or without this, let's say, sustainable access to cooling. And this also results in huge energy requirements if we were to provide them, if we were able to provide these people with decent housing and cooling. So approximately 3.5% of global electricity consumption today. We've also been looking at the drivers going forwards, and so how can we model people's access to cooling in the future? And this is largely driven by growth in population, people's affluence, and whether they can afford air conditioning, and whether they have access to electricity, which is obviously important, and then also a warming climate. And what's difficult is that particularly in South Asia and also in sub-Saharan Africa, it appears that the population may, depending on the socioeconomic scenario, may be growing faster than people are getting wealthier. And so the number of people unable to afford access, let's say, to air conditioning would actually be growing in the next 20, 30, 40 years. That means that a growing number of people exposed to heat stress, even if we don't take climate change into account, which is not even realistic. We know that this problem was going to get worse for at least the next 30 years in the best case scenario. Yeah, so we're at about 1.2 degrees of warming today, and this will definitely exceed 1.5 in the best case. So how can we reduce the risks? Because I think it's not possible to eliminate them. I try to put here on the slide a few simple aspects, both related to mitigation and adaptation. I wasn't able to box them because I think there are some overlaps, but a wider societal...
Start wrapping up, please.
Sure, this is the last slide. Wider societal approach to both mitigating for climate change and also adapting to the impacts. So this means access to cooling technologies on the simplest level. This means providing access to fans and ACs, but also ensuring that the efficiency of AC is improving and also that these are affordable. In terms of electrification, people working in energy, obviously we need decarbonization of the grid to mitigate. We can also provide, where we can't provide this individually, community cooling facilities and ensure that electricity supply is reliable and affordable. And lastly, more widely within society, this needs decent housing and communities. And so improving the quality of homes means planning houses as opposed to letting informal housing proliferate, using improved materials and design that reduces energy requirements, but also improves thermal comfort, green spaces and shading, improved natural ventilation, not just within homes, but also within at the street and the, let's say, neighborhood district level, and preparedness and resilience. So early warning systems, being able to look after our old and vulnerable parts of society to reduce the risk of heat waves. I'll leave it at that, and thanks for your attention. Look forward to continuing the conversation.
Thank you, Dr. Byers. That was an excellent presentation. And in the interest of time, we'll go ahead with the other presentations and take questions right at the end. So our next speaker is also joining us online, Professor Madhumita Chatterjee, professor at the Acharya Bangalore Business School. Her interests lie in the areas of organizational behavior, ethics, corporate governance, corporate social responsibility, business histories, etc. And her latest book on corporate social responsibility has recently been published as well. So Dr. Madhumita, over to you. If you could keep your presentation to about 7-8 minutes. Can you hear us? Yeah, you may start.
Are my slides visible, ma'am?
Yes, your slides are visible.
Okay. Thank you very much for giving me this opportunity. Good afternoon to the chairperson and all the participants in today's session. I'll be presenting something on the human dimension of transition and sustainability in the energy sector. We are trying to do a comparison between India and Sri Lanka. My Sri Lankan colleague has not been able to join us, but she has shared her slides with us. I have my another colleague, Dr. Soma Vishwas, who will be joining towards the end of the presentation. So,
Ma'am, can you please put it on the presentation mode?
Is it visible now? Is it okay?
Yes.
Yeah, okay. Thank you. So what the objective of our paper was to understand the attitude of Indians as well as Sri Lankan consumers towards implementing renewable energy in their organizations and homes, and the level of awareness among the consumers and their readiness to adopt the change and their willingness to invest in implementing renewable energy, and how the attitude of customers is influencing the renewable energy adoption. Because we feel in these two countries, especially in most of the Asian countries, there is still a reluctance to move to the green energy that we are talking about. So that's why we felt it was necessary, because we have been talking since the beginning that how important it is to move towards green energy, reduce carbon footprint, reduce fossil fuels. We've been talking about it, and we are seeing what's happening in Europe at the moment, the heat wave. So it's important that we look at this and influence our customers to move towards it. So that was the idea that made us look at this. So at present, if you're looking at the green energy, a simple this thing about India, India is growing towards adopting it. In fact, I'm proud to say our institution is totally run on solar energy. So there are many organizations and institutions who are trying to move, but there is still a long way to go. So we have an renewable energy capacity of, excluding the hydropower, 92.54 GW out of 5.47 was added in the period April 2020 to January 21. This is a secondary data that we have collected. So I'll not go too much into the secondary data because they are available. I'll move towards what are the challenges that we faced while doing this research. So these are some of the initiatives that Government of India has taken in the Ministry of Renewable Energy Source, and we can see that there is a movement towards moving towards renewable energy. And as our chairperson has been speaking, that certain targets have been kept for us, where India is planning to become carbon neutral and also move towards green energy. Now, this is the energy map of India. This is the current status that we are in. And we still have a lot of coal mines, and our human aspect, as we are talking about, is the people working there, what are their conditions, and also about the affordability of the consumers whom we want to who we want to change from the fossil fuels to the renewable energy. So the strategies that have been adopted till now is about the green cities, developing renewable energy and hybrid projects, ensuring round-the-clock power supply, draft electricity rules, decentralized solar power, shift towards non-conventional energy. These are the factors that the world is looking at, and these are something that as a country we also have to look at very seriously. Now, in the Sri Lankan sector, not much was available considering the present situation. We did get some data on it, of course. So this is what Sri Lankan sector is looking at. Of course, they also want to become self-sufficient by 2030. The demand is 10,500 gigawatts, and that is what they will have to create in their country. And this is the renewable energy resource potential that is there in the demand supply that is available to them. So the energy sector also has set some targets in Sri Lanka, but we have to see, as per my colleague, how far these would be achievable considering the present economic scenario and what they are going through. And so one of the issues that was discussed was that when we give electricity free, are there issues that we have to look at? And if we move to green energy, how do we ensure that that is acceptable to the people? And how do we reach out to all the people who need to use it? So there is what we have to look at is reducing the petroleum fuel, especially in the transport subsector, by 5%, introducing alternative strategies. And this was supposed to be done by 2020. Produce petroleum product demand throughout the country, and upgrade the quality of gasoline and diesel, enhance the quality and reliability of electricity, broadening energy sector investment, and carbon footprint in energy sector should be reduced by 5%. But these are the challenges that are there. But the problem is about the consumer accepting this. There is still not much awareness about why the green energy should be accepted, and the cost behind it also forces them not to look at it. So how do we go about these particular aspects is what we are trying to look at, and how do we convince the consumers? There is also a need to convince the so-called industry owners and managers to move towards green energy, because it is going to be costly. But this whole convincing part, that is the human aspect that we are trying to look at, and how, though many people may not be involved in that particular industry, they're getting impacted by those industries' products. So that is the sustainability level or the CSR concept that needs to be broad-based and understood. So this is the Sri Lankan this thing. I'll not go too much because there is not much time for us. The methodology onwards, my colleague Dr. Soma will be talking. One of the factors that we found is there is also the challenge that very often the consumers say, since the sources of green energy are generally free, should they not be getting energy at a much lesser amount, and the government should be subsidizing this? So we come back to the same circle of saying, if the government is going to subsidize, is it possible to supply electricity to all? So while we were looking at it, these were the questions that came up. So now I'll request Dr. Shoma to carry on from here. Dr. Shoma, can you join, please?
Yes, ma'am. Can you hear me?
Yes, we can.
Be a little fast,
Just one.
about 2 minutes.
Yeah, actually, this work actually we are doing from the Indian and the Sri Lankan perspective. So we have done a small, we have carried on a small primary data survey, particularly on Indian perspective, basically in the states of India, and here the paper here is followed actually the qualitative approach and to understand the attitude of the industrial as well as individual customers. So we have talked to those people who are the industrial partner people as well as the individual consumers, and generally we have collected the data from the two states, the South Indian part and east part. So total 30 respondents, and actually we are planning to improve work on it, and we will be actually getting some primary data on that. So, ma'am, can you please here actually 40%? So we have worked on that. We have taken some in-depth interview, and from there we did a thematic study And this is it is coming like this. There are four factors came out. One is the ma'am, the first slide, ma'am, and we just the awareness here what we found that state-wise it is they're basically different. The awareness are different. In the institutional heads, they told that they are aware and they are also using it. But for the individuals, generally there's a big gap. Actually, the people they are actually they don't have much knowledge about the renewable energy sources, as well as they are not also in the position to somewhere the big societies where they are housing projects, they are incorporating some solar panels and renewable energy sources. But as an individual, if we go by the individual, there is a really big gap, because the storage, the government, even they are not aware about the government subsidies and all. And intention to use the next factor was intention to use. So where we found that the institutional heads, the institutions, they are actually going for the green campus projects and all. They are using really they are more using the solar panel. Here also, if we talk about the wind power and other renewable energy sources, they are not much used, but solar panels are used. Solar system and individuals are generally not planning, and intention to, we have not seen as a very low. It is actually 0.6%. It is coming out of that. Only 2 people, they are telling that is basically these 2 people are also for those big housing projects who are actually.
Please wrap up. We are running out of time for this.
Ma'am, last.
Just flip through the slides. You don't need to read them out. Yeah.
Okay. And the availability and the cost. So here basically the availability as it is, of course, the solar panels are available, but the wind power, and it is not much it is not available as at the institutional level, and the individual level also. Individual is not at all available. Costs are also very high. Sometimes subsidies are not understood. And the last slide, ma'am. So basically, what we found that the awareness are very low, and the installation, and we're here actually, if we look at this, this is not affordable much about the individual consumer. Ma'am, last can we go for the last slide, ma'am? Yeah, basically what we found that we have to promote more awareness among the individual citizens and the related to the benefits and utility of the renewable sources. What we found that if we can do some community hubs, if we can community energy hub where the society, the people of the community, like a small housing project, they on the subscription basis, one club or one unit, they can have the solar panels and all, and from there, if it is possible to distribute to the households. So that may be one mode, and that came up with as a suggestion from them. And some skill trainings are really needed. Competitive rewards are needed to promote the human resources, and we have to also encourage the human societies and incorporate the sources and so that they can incorporate more and more use the renewable energy sources. Ma'am, please.
Okay, I just wanted to add that we were looking at system thinking, which is looking at interconnectedness. The world is an interconnected web where
Madhumita, can we close this now? We need to move on to the next speaker, please.
Yeah, so that is why when we were doing this, we found that there are many areas which we will have to enter. Just looking at the green energy is not going to be sufficient. So this is a work in progress, and we just wanted to say up to this point, we have found this, and we still need to move ahead with this.
Sure. Thank you so much.
Thank you.
Yeah.
Thank you.
So we'll quickly move to the next presentation, which is by Professor Eric Zussman. He's a senior policy researcher and area leader at TIFAC in Hayama, Japan. For the past 2 decades, he has been conducting research on environmental issues in Asia and is currently also serving as a lead author for the 6th assessment report of the IPCC. The topic is related to bringing institutional and social feasibility into assessment modeling. Eric, the floor is yours.
Hello, this is Kaoru Akahoshi from IIAS. Well, actually, I am presenting today's research together with Dr. Eric Zessman. Greetings from Japan. I'm starting now, and Eric will come in later. Our study is about the assessing barriers for implementing of emission mitigation measures. Next slide, please. So this is the outline of today's talk. Well, actually, previous speakers spoke about their challenges and of implementing green energy policies. It was quite interesting, and it's relevant to our research as well. Okay, let me start with the setting the context. We, our international community, have 1.5 or 2 degrees target scenarios. And in order to achieve these targets, countries have been requested to make efforts towards higher and more ambitious reduction targets. This will involve not only CO2, but also SLCPs, such as black carbon, as highlighted in high-level reports like IPCC reports and peer-review literature. They're also looking at the feasibility of meeting ambitious climate goals. Scenarios show as desirable pathways, but what's happening in the real world? We need better understanding of the feasibility of scenarios. Therefore, we set our research focus on the feasibility of implementing SLCP solutions in Thailand, with assessing barriers of those solutions with economic, technical, social, and institutional barriers. Next, please. Okay, so research objectives. We are trying to estimate how much these barriers affect feasibility and slow diffusion of those solutions, and the cost to overcome social and institutional barriers. Then our goal is to strengthen integration between barrier analysis and modeling scenarios. Actually, this is a 5-year research project, and we are now in the 2nd year, so we are now on the way. Next, please. Okay, there's a list of things I hope you can see, but the things are key SLCP solutions in Southeast Asia identified IIASA gains models. We picked up several black carbon mitigation solutions among them to assess their barriers, namely clean cooking technology and cleaner fuel from household energy sector, emission standards, vehicle inspection and maintenance, and e-vehicles from transport sector, and open burnings of crops from agriculture sector. Next, please. And we took 3 steps. First, we conducted expert survey on effects of barriers, and then literature review to do quantitative assessment of barrier effects. Then we combined both survey results to assess the size of barriers. Next, please. This shows results of the combination of 2 surveys. First, we consider how much these barriers slow implementation of policy or diffusion of technology. You see the bars. The red bars shows the size of technical barriers. Blue bars represent economic barriers. Yellow color represents social barriers, and green represent institutional barriers. The horizontal axis represents the number of years of delay. I'm not going to get into details now due to the time constraint, but what we found from our survey are mainly three things. They are implementation of solutions gets slowed by between 6 to 7 years over 10-year period for all solutions when all barriers combined. social and institutional barriers are as large or greater than technical and economic barriers in many cases, while these social and institutional barriers are not typically included in assessment models. From here, I'd like to invite Dr. Jessamine for the latter half of the presentation. Eric, could you come in?
Thank you very much, Kaoru and Ritu. I know we have a quick timeline, so I'll move very fast. Basically, what we did from here is we tried our best to, I'm having problems shifting the video right now. We tried our best to estimate the costs of overcoming some of these barriers. And to do that, we worked with experts in Thailand to understand what are the current costs of implementing programs like cook stove programs, and what are some of the additional costs that might be needed to accelerate diffusion of clean cook stoves. And I'm going to try my best to stop the sharing for a second and see if I can reshare. So let's see if we can do that.
The slides from here.
And so as noted previously, the years delayed for cook stoves are approximately 7 years for all the different types of barriers. And if we're just looking at social institutional, it's about a 4-year delay. And so then to estimate the costs of overcoming those barriers, we compared, as I mentioned previously, the amount of money that was allocated for cook stove programs. This is just showing you 2023 and 2024. It's planned allocation. And the yellow part is the part focused more on the social barriers, awareness raising and training. The green part is more about the institutional barriers. So this is how much it costs to design and implement a policy. And on the left-hand side, that's a business as usual situation. And the right-hand side, then we work with experts to determine what would be additional amount of resources allocated to overcome those barriers. And you can see that the resources are actually perhaps much smaller than the existing program, but this has a lot to do with sort of designing an ideal type of program for cook stoves that would focus on training and capacity building and co-design of different policies, learning and development. And so one of the things that's implied here is that the resources that would be allocated to overcome some of the social institutional barriers, perhaps not so great. It might be much less, for instance, than the resources allocated for overcoming some of the technological and economic barriers. And this is how those resources would look like over a 10-year period. Notice there are some up and downs in terms of this, especially this additional program, and that reflects the fact that the program is designed to run for 5 years and then restart again in another 5 years and hopefully end in 10 years to the point where many of the cook stove issues, at least in Thailand, would be overcome. Okay, so this is our sort of concluding points and way forward. Many models may overestimate the real world prospects of achieving climate, and I would also say SDG goals. And what we try to do in this paper is bring in some of these excluded institutional and social barriers into some of the modeling frameworks in a way that can communicate with the modeling. So you notice we emphasize a lot on money and time. Those are two languages which we see as really relevant to connecting some of the more qualitative work on barriers analysis with the quantitative modeling. We make the link to real work costs by estimating how much barriers slow diffusion, as well as the costs of overcoming barriers, once again, money and time. And we're currently in the process of bringing these barriers into two different types of scenarios, one scenario with and without barriers, and to demonstrate their effects on emissions and their related co-benefits on air quality, health, what have you. And then our other steps are detailing the enabling reforms that can overcome these barriers, which I think connects nicely with some of the other previous presentations. Things like enhanced institutional coordination, vertical integration between different levels of government, and awareness raising, co-design type programs. And that's all we have. Thank you very much.
Thank you so much, Eric and Akahoshi. The next presentation is by Dr. Rohit Chandra, who's joining us physically here. Dr. Chandra is an assistant professor working primarily on energy infrastructure and state capitalism. His recent work has covered the coal and power industries, and his research interests include infrastructure finance. Over to you, Dr. Chandra. We'll also be speaking on just transitions in the Indian coal industry in terms of the problems and prospects of the sector.
Hello? Yeah, okay, perfect. This is working. Thank you so much, Ritu, and thank you to IIASA and TIFAC for inviting me for this conference. So I'll, in the interest of time, go very quickly through some brief comments on my view on kind of just transition conversations in India today. So just waiting for the slides. Okay, next slide. Yeah, so just very briefly, kind of the just transition idea evolved from primarily, I think, initially the 1970s politics in the US, right? So union workers, in particular, Tony Mazzocchi, were known for asking for a worker super fund when the US EPA was first established, and basically a lot of people in chemical, oil, and atomic energy were losing their jobs at the time, right? Over the last 50 years, this concept has been adopted by various organizations. I think most people in this room and in this conference probably know the just transition framing quite well. But I think the ITUC formulation is particularly good. I won't read it out, but you can find it afterwards. Next slide, please. So I think a lot of just transition framing so far have been about loss aversion, right? So it's about understanding the radiative effects of shutting down fossil fuel industries on local economies. And this is particularly true, I think, in developing countries where the loss aversion impacts tend to be fairly large, both in terms of employment, family impacts, local economies, all of these kinds of things. And so it's not only this direct employment numbers, right? But it's also upstream and downstream employment related to fossil fuel industries. Most importantly, informal employment, which is massive, and then also the broader welfare effects of the recession of these industries from these areas, right? And I'm a political scientist and economic historian who works primarily on coal. And so, there's a massive impact that the recession of coal over the next 30, 40 years is going to have on these regions. And I'll talk about that in a little bit, right? So it's not just the industries, but also the infrastructure they've built and kind of the entire cities and towns that they've financed over the last four to 5 decades, which are threatened by all of this money leaving these places, right? And so, I mean, I think anyone who's arguing for the immediate cessation of coal has no social imagination and has never been to these areas, right? Life in the coal belt depends on coal for a reason. And this is not just, kind of the 50,000 to 100,000 jobs of kind of Virginia or the kind of US coal industry. This is actually tens of millions of people who are going to be impacted, right? And so I think these are the conversations which the international just transition conversations are finally acknowledging that this is going to happen and trying to build in some financial mechanisms in between. Next slide, please. So I think part of it is, and this is what I think everyone is struggling to articulate, both in the research community and politically more broadly, that what is the economic future of these areas, right? So over the last 50 years, the coal sector has been a huge locus of political mobilization, not just for unions, but also for larger political financing. And it's a major source of economic dependence in these areas, right? So my guess is that, in fact, are larger than some of the numbers that I think Ritu presented earlier, that it's 10, 15 million people dependent on coal for daily livelihoods just in coal, right? The economic multipliers are massive, and no one has really bothered measuring them for the last 30, 40 years. So we're trying to figure that out now, right? And frankly speaking, I'm very pessimistic about any kind of coal to renewable energy transition in Eastern India anytime soon, right? I'll show you some maps along these lines, but it's not, anyone who thinks that green jobs are certainly going to take over the coal belt is sorely mistaken, at least in the next 5, 7 years. And so this map just shows you the radiative impacts of coal, right? It's just buffers drawn around a population map around coal shape files. And you can see that there's 50 million people who live within 50 to 100 kilometers of coal mines in India, right? My guess is at least a third of all of these people have some part of their livelihood dependent on coal. So this is something we need to understand better. And this is still 30,000 feet, right? So we need to get closer to this. Next slide. So this is what median coal-related employment looks like in India, right? Lots of people have shown these kind of cycle wala pictures at this point, but I think it deserves mentioning that of the, maybe roughly 300,000 people who are formally employed by the coal industry in India, and maybe a few 100,000 who are contractually employed, but there's millions of people who are doing these kinds of things on a daily basis. So at one level, if you get them to do something else and you have those economic opportunities, I'm sure they'd love to move, right? But at the same time, that's precisely the problem in these areas. Next slide, please. So this red box represents about 95% of India's coal production. There's some coal that happens in Western and Northeastern India and in Southern India as well. But for the most part, this is the region we're focused on. And I think even Ritu has shown some of these kind of maps before about this geospatial mismatch, right? So that red box is the majority of the Indian coal industry. Next slide, please. The red parts of this map are where India's prime solar and wind resources are. There's literally no overlap. Over 95% of India's grid-based RE production comes from those red areas at this moment in time, right? And that also drives private investment in those areas, not surprisingly. So this is where some of my pessimism of this green transition, kind of silly discourse comes from, that it's not rooted in reality in any sense. Sure, I mean, you can put panels on rooftops and build small solar plants, but the big private investment is happening in these states for a reason. And hopefully that will change over time. I remember I was having a conversation with someone at GIZ who said, even in Eastern India, the best solar, the worst solar spots in Eastern India are still better than the best solar spots in Germany, right? So, I mean, there is insulation there, but kind of the comparative politics and comparative economics driven by a private sector led energy transition, especially in the renewable energy space, makes it that you don't have that many people taking risks in those spaces, right? So that's where you need policy to step in. That's where you need to understand regional economies better. And I think a lot of our techno-economic imagination just comes from the 4 or 5 really developed states who managed to do this well, right? Next slide, please. I think just transitions also require institutions to think differently. I think institutions like the IPPCC and the UNFCCC are singularly not good at thinking about anything related to local politics in large states, right? So what was the presumption behind the UNFCCC processes? That everyone makes their climate commitments, puts up their INDCs, and they figure out their local politics. I think in the last 5 years, they're realizing, oh, we may actually have to understand these things a little better and encourage those transitions because it's much more complicated, right? And in some senses, at least my, I've worked in this space in the last few years. I've advised a bunch of these kind of bilateral and multilateral aid organizations. The bilateral organizations are far better at this so far than the multilaterals, in my opinion, right? Partly because I think they're working with states and state politics far more constructively rather than just leaving it to capital-based agency, right? I mean, a Delhi-centric just transition is not a just transition, right? You need to go to Ranchi, you need to go to Calcutta, you need to go to Bilaspur, all of these kinds of places for those conversations. I think the other thing is that, and then this is where kind of the indignant political scientist and economic historian in me comes out, is that you actually need to consider politics, labor, business, all of these different actors, right? So after a point, this is not like an economics and modeling question. This is about describing local areas better, understanding the economies, all of these kinds of things. So frankly, like the people who are trying to model just transition at this point are kind of missing the point. Go to those places and understand how they work before you start running models, right? After a point, there isn't good data on a lot of these places in their local economies. No one's bothered to like measure things properly there for the last 3 decades. I think there's a lot more descriptive work that needs to be done before you get to the levels of sophistication that lead to all of these fancy models. And so it requires building communities, a lot of consensus, a lot of compromise. These things take time. 1.5 degrees Celsius is an illusion. It's not going to happen, right? So I think even national governments and national capital ecosystems cannot provide you with all the answers, which is why every competent research organization under the sun is actually going to these places, right? iForest is working in Korba and Ramgarh. Harry is working in Betul. The World Bank is trying to do stuff in Bokaro. They're finally realizing that going and spending time in these places will actually help you with those just transition conversations better than high-level analysis. And I think the other thing is that like the typical tripartite consultation model is more difficult in developing countries generally because of the multiplicity of unions, right? So even if you get all the unions into a room to have these conversations, these things take time. So just last few slides. Next slide, please. So what can we do about it, right? I think I've mentioned some things before, which is that, economic transition planning and scenarios help, but also like very specific regional district level analysis helps. I've mentioned some of the studies that have happened before, but we need those for the 20, 30 coal districts that exist in India. And it isn't happening within government, frankly. So it is civil society and the research community which will end up doing most of this, right? This requires social scientists and researchers on the ground, not economists and modelers, as far as I'm concerned. Or you need the old school economists like Albert Hirschman, who actually went out to the field and did things, right? Rather than sitting in front of air-conditioned rooms with computers. I think understanding the political economy of public sector organizations is really important because they're the ones who work in these regions. Coal India can probably do more for a just transition than about anyone else. So you should work with Coal India rather than having scattering of civil society around which can do small things in small places, right? Coal India can actually do pretty big things. To get Coal India to think in these directions, that takes a lot of work, right? And there are people working on this. Just 30 seconds. I think also understanding how these enclave economies, places like Jamshedpur, Rourkela, Angul, all of these came up. More descriptive work, more histories, economic histories helps. Where is the next generation of industrial investment in the coal belt going to come from, right? You go to some of these states, private investors are not particularly enthusiastic about putting money in. So you actually need industrial policy, state investment, all of these kinds of things. And then is the money, is this all this JT money, just transition money flowing into the right kinds of places, right? So elaborate mine closure plans like what Coal Ministry is planning with the World Bank right now is a start, but actually what you need is a broader economic diversification plan for some of these coal regions, right? So I think there's a lot of experimentation happening in this space right now. I think it's quite a fertile space. I'm happy to have conversations with people afterwards about anyone who's interested, but it is very experimental. And after a point, the value of modelers in this work is fairly limited. So I'll stop there.
Thank you, Dr. Chandra. The next speaker is Ms. Purva Israni, who's again joining us online. She's a public policy graduate who's interned with organizations such as UNDP and the Asia Foundation in the fields of clean energy, green mobility, and green economy. And the topic she'll be speaking on is urban energy systems in India, insights from complex systems thinking. So over to you, Purva.
Just to confirm, my screen's visible, right?
Yes. Yes, if you can just go to presentation mode.
Right. So good afternoon, everyone. Thank you so much for this opportunity. And today I will be speaking on the need to comprehend the challenges of transitioning towards sustainable energy systems and how it appears desirable to use insights from complexity theory to understand the intricacies of the urban energy systems. So this research was conducted by Professor Naresh Singh, my mentor, and I will be presenting on his behalf as well. So, this research emphasizes the need and the approaches to recognize urban energy systems as complex systems due to the presence of factors such as multiple stakeholders, the interconnectedness of the agents, the changing dynamics in it, and the adaptive processes in the systems. So, in this, we have taken the case study of Bhopal, Madhya Pradesh, and considered its urban solar city master plan to better understand the a sense of the complex energy systems. So, through this, the intention is to explore how examining the urban energy systems through the lens of complexity economics and systems thinking can be valuable in formulating policy interventions towards sustainable urban energy transitions. So, as we know that the path to achieving a low carbon economy significantly entails the substitution of fossil fuel based energy options with renewable energy alternatives. So, decarbonization of the energy sector is critical to reduce energy related carbon dioxide emissions. And globally, the majority of the energy usage has been in urban areas. The data shows that approximately 75% of the final global energy is used in the urban areas, and these urban areas are responsible for approximately 78% of the global CO2 emissions. And contemporarily, India is the third largest energy user in the world, contributing to 7% of the global anthropogenic greenhouse gas emissions. So, Also, the data from Oxford Economics shows that 17 amongst the top 20 fastest developing cities in the world are situated in India, out of which Surat being at the top of this list. So this urban evolution will include energy provisions for residential and commercial buildings, urban mobility, and other urban spaces, eventually adding to the global energy consumption. So this urban expansion is thus opening up an important opportunity to incorporate and expand renewable energy infrastructure along with improving the efficiency of energy usage. So in this background, it can be implied that a thorough understanding of the urban energy systems in India can be central to sustainable energy transitions and climate change mitigation measures. So, the energy systems comprise a range of stakeholders such as producers, suppliers, distribution companies, and end users. In the process of advancing towards energy transitions, the diverse range of agents in the energy systems can frequently have conflicting objectives. So, to accommodate the different stakeholder paradigms within the urban energy system, the governance structures have to consider the complex nature of the energy systems. These systems are commonly called and can be known as socio-technological systems that have interconnections with the political, environmental, and even economic landscape of the urban areas. So these intersectoral linkages and the constant evolution of the stakeholders' priorities and relationships, along with their conflicting objectives in the urban energy landscape, can make urban energy systems a complex system. So, complexity theory provides a conceptual framework, a way of thinking, and a way of seeing the intricacies of the world. Urban energy systems can be said that they are largely composed of three elements: agents, objects, and the environment. The agents in the system interact with each other through networks under the influence of institutions and regulatory bodies, and we can say that they tend to have properties of adaptation and transformation. The objects change over time according to economic, political, and environmental circumstances. And the third element is the environment, which encompasses social, political, and cultural facets within which the urban energy systems operate. So the elements in the urban energy system share information and learn from each other and are of dynamic nature. So against this background, urban energy systems can be understood as complex systems that have diverse and interrelated agents or objects. So in order to better understand the properties of complex urban energy systems, it is desirable to characterize the complex systems in conjunction with their applications to the urban energy systems. So for example, amongst the characteristics of complex systems thinking, we can say that, for example, if we take networks, so in urban energy systems, there can be physical and social networks. For example, there are network interactions among households or end users, power generating companies, and distribution companies. So the network interactions between the agents and the technological environment in urban energy systems can help in understanding the user behavior and preferences, which can be different for diverse agents. So, for instance, the preferences and interactions of large corporate bodies will differ significantly from the demands and preferences of emerging startups and organizations within the energy systems and for energy transitions. So, second example that we can take is of feedback loops as a characteristic. So, from the perspective of urban energy systems, increased investments in the clean energy sector can feedback directly into creating increased jobs and uplifting the local economy. So, focus on the national green energy system has the capability to increase benefits for an economy, which further can tend to create a cycle of environmental gains along with economic gains. Let's come to the case study that is the main part of this presentation. So, with the increasing focus of the government's policymakers and development professionals on sustainable development, the focus is now shifting from linear approaches to multi-dimensional aspects of governance and advancement. So, to understand the multi-dimensional approaches needed towards effective urban sustainability governance, let's have a look at the Bhopal Solar City Master Plan and the challenges that the plan is facing and has faced in the past. So, Bhopal is the capital city of the state of Madhya Pradesh, which is located in the central part of India. It is situated on a hilly terrain within the Malwa Plateau, and the city is well connected through rail, road, and air, and can be said that it is a major hub of educational, political, administrative, along with as well as industrial activities. And Bhopal is also one of the cities in the state that drives the economic progress of the region, and hence it can be viewed as an attractive destination for investment. So, Bhopal has a hot summer season, mild and dry winters, with a humid monsoon season. However, of late, global warming has been impacting the city of Bhopal, its famous lakes, and its huge green cover. Also, according to the data from UNEP, Bhopal's temperature has been increasing by 0.07 degrees Celsius per year, which can be considered as a large increase as per the climate change trends.
You
Keeping
have 2
that
more
in
minutes, please.
Sure,
Yeah,
ma'am.
thank you,
So,
ma'am.
against this background, Bhopal aims to utilize its land parcels towards making itself a sustainable urban habitat. And it is one of the cities to be selected by the Ministry for New and Renewable Energy to be advanced under the development of Solar City program. So this plan has been disappointing in terms of physical advancement, and this can be attributed to delayed disbursement of funds from the government, unsatisfactory project planning and monitoring, delayed procurement planning, insufficient institutional capacity, and lack of stakeholder consultation. Also, there is lack of social awareness amongst the households and individuals for renewable energy and energy efficiency. Also, additionally, the planning of the Municipal Corporation of Bhopal towards making the city a solar city has paved the way for encroachment possibilities around the catchment areas of the lakes. And this has led to conflicts between the citizens and the government administration, as solar infrastructure near the lake areas can damage the water ecosystem of Bhopal. So, coming directly to the policy recommendations, since we are running out of time. So, urban areas and their energy systems have immense potential uh, for sustainable transitions. So, the following policy recommendations and key aspects can be adopted by the policymakers in the city of Bhopal, and also overarchingly in the city in other urban settings to stimulate the sustainable energy transition practices. So, the first point can be that the policymakers should avoid the possibility of failures. So this approach of anticipatory management practices will build the skills of the policymakers and leaders to foresee and adapt to emerging or actual adverse situations. Also, for progressive transitions to renewables, along with the accelerated sustainable energy infrastructure, the emphasis should be placed on integration of social practices and technical innovation to capacitate the dynamic interactions between the renewable energy sources and the energy end users. Also, third point also can be that the capacity building of the working staff and personnel is very important, and in this area itself, to enhance their capabilities, and outlook of complexity informed leadership can be adopted. So this will assist the leaders at the senior level to question the linearities and direction of changes in the urban energy systems. Also, this goes without saying that when we are looking at the models, so sense making tools can be helpful in dealing with complex situations. So in this context, sense making tools and techniques such as the Stacy matrix and the Canadian framework can be used, and these can offer the policymakers and leaders to equip themselves with the appropriate lens to view the contemporary and prospective approaches concerning the sustainable urban energy systems. So to conclude, I would like to say that, however, at present, complex systems thinking provides a significant starting point to think in a certain way about sustainability and other potential domains with significant development gaps. This field of study can have influential impacts on designing interventions towards sustainable urban energy systems, and also those complex systems thinking is in its initial stage, yet it is capable of providing important contributions towards solving the global sustainability crisis.
Thank you
So,
so much.
with this, I end my presentation. Thank you, everybody, for your attention.
Thank you. Next speaker is Dr. Kaveri Ashok. She's a senior associate at CSTEP, currently involved in a project which is examining energy and emissions implications for the desired quality of life in India. Her interests include policy analysis and low carbon energy strategies. Over to you, Kaveri, and please keep to about 7 minutes. Our topic is on sustainable alternative futures for.
The stage has been set beautifully. Well, fellow speaker. Today I would like to talk about Safari model, which stands for Sustainable Alternative Futures for India. So the key messages about Safari is that it is essentially a simulation model built using the principles of systems thinking to model India's long-term development pathways. And it includes all parts of the system, including development goals, energy supply and demand system, resources, and environment in totality. What it can help you do is to build multitude of scenarios, like Professor Banerjee was saying in the plenary, not necessarily least cost optimized, and also build sectoral strategies towards low carbon pathways or net zero emissions, as well as identify unintended consequences of any policy actions or choices that are made in any of these sectoral strategies, and so on. To set a bit of context, like Dr. Mathur was saying, we all know that India is committed to climate action. Most recently at COP26, we have committed to enhance 2030 targets and a net zero target year by 2070. At the same time, India also has severe human development challenges to overcome, such as affordable housing shortage to the tune of 30 to 40 million houses, poverty, 24/7 access to electricity and clean water, and nutrition and food security for a growing population, etc., etc. So climate or environment and development is usually looked at in isolation in a typical modeling environment. Interlinkages are often not explored. So what we set out to do is to come up with a framework to navigate the balance between development and climate action and to see how it can be achieved in a sustainable manner. In other words, to look at a decent quality of life and what are the energy and emissions and material consequences of achieving it for the entire population of India, for the growing population of India. In fact, this is a concept that has been gaining considerable traction even in mainstream climate dialogue. For example, the recent IPCC report for the first time in its history, has a report dedicated to demand side measures, the core concept of which is to achieve decent quality of life with more sustainably and in a less emissions intensive pathway. So with this motivation, we set out to build the Safari model, which is a user interactive simulation model of India's mid-century development pathways built as a decision support system. Like I said, it attempts to include interlinkages between the goals, sectors, and understands policy trade-offs between choices made. The use of achievement of human development goals as a metric for development rather than classical macroeconomic parameters like GDP alone. On the left side, on the right side, there is a snapshot of the user interface that I have provided. So this is just the beta version of the tool is now available online for the users to experiment and develop their own scenarios. The development goals that we have considered are very much in line with the sustainable developmental goals. These are the 8 goals that we have considered as the driver for the model. They look beyond 2030, India specific, and have a direct bearing on energy demand and emissions. The benchmarks that we chose were set based on extensive literature review and stakeholder consultation with government, academia, and industry. So this is the basic Safari framework. It has, like I said, it's mainly driven by the development goals, and it also has socioeconomic parameters driving it, such as population, urbanization rate, and GDP. And these drive the demand sectors, which are essentially agriculture, transport, buildings, and industry sector. And these sectors have interlinkages among them as well. And the demand from these industries then drives the power sector of the model. And then the key outputs will be total emissions and resources. So the way a user can use this framework to develop their own scenarios is through demand side interventions, of which we have 80 and counting right now in the model, and can be categorized into policy ambitions, technology options, and behavioral shifts. And just to give an example, a flavor of the kind of integrated scenarios that can be made using Safari, we have analyzed bunch of integrated scenarios. So the reference scenario is where the development goals are met without much consideration to environmental indicators, energy, and emissions. Then we look at two different sustainability scenarios. Level A, where the development goals are met, but on a lesser emission intensive pathway by adopting technology and efficiency improvements that are relatively easy to achieve. And then we have sustainable development B pathway, wherein the climate and development are given equal urgency, and on top of more aggressive technology and efficiency improvements, we also take into consideration behavioral shifts. We also look at a scenario called overconsumption, where India aspires for living standards and consumption patterns in Western countries. For today's presentation, I will just take you through the results of reference scenario vis-a-vis sustainable development B, wherein behavioral shifts play a significant role. So these are the reference scenario results. It's a relatively new model. So the projections are till 2050, and it calibrates well with established models like IES from NITI Aayog and IIASA and IEA projections. So as you can see, electricity demand, both electricity demand and final energy demand, are set to increase steadily till 2050 with no sign of plateauing. And residential electricity demand in 2050 will be around 4,000 kilowatt hour per household per year, which is around today's average consumption in Europe. And final energy per capita will increase to around 33 gigajoule. And in the sustainability scenario, this you can see that it is reduced considerably by about 30 to 40% in both electricity demand as well as final energy demand. We see that with some key behavioral levers, it's possible to achieve the development goals with residential electricity demand continuing at the current average levels, as well as final energy considerably reduced final energy per capita demand of around 25 gigajoule. The key behavioral levers that resulted in this kind of result is in the building sector, appliance usage patterns or use of alternative construction materials, which not only reduces the embodied emissions, but also reduces the requirement for energy for space cooling. Then dietary shift towards lesser meat and lesser water intensive crops in agriculture sector. Shared and public mobility and reduced travel demand due to factors like teleworking in transport sector, and increased material efficiency, or what we call circular economy, in the industry sector. These are the key behavioral levers that resulted in a reduction that we saw of around 30 to 40%. Now, this kind of reduction in energy demand also has second order impact on the supply scenario, which we will see now. In the reference scenario, you will see that the operating capacity is had to increase quite a bit by 2050 by around 4 times. And the power generation share, 1/3 of the power generation share will still be coming from coal even in 2050. And the demand for coal, therefore, is set to double by 2050 from today's demand. And this is despite RE cost reductions considered for solar, wind, and battery storage. But it's interesting to note that fossil-free capacity in 2030, we will be achieving the 50%. We will, in fact, overshoot our 50% target. And in 2050, we will be able to achieve 64%. But with the reduced demand that we saw and the achievement will be even greater. So in the sustainable scenario, the power supply, you can see that the operating capacity requirements are much lesser, and increased fossil-free capacities share is possible. Even in 2030, we are able to achieve the reference case scenarios 2050 levels of 64%, and around 80% by 2050 is also achievable in this sustainable scenario. The coal demand can be maintained at current levels also in this scenario. Now, in terms of GHG emissions, you can see that the annual GHG emissions is reduced considerably, and it is plateaued by 2040 in the STB scenarios and continues to plateau till 2050. And on the right side, the waterfall graph shows the impact of levers in different demand sectors to result in this reduction in cumulative GHG emissions from around 100 of around 25 to 30 gigaton per carbon dioxide equivalent.
Kaveri, could you wrap up, please?
Yeah. So there is significant contribution to reduction in emissions via demand side interventions is the key message. And the way forward is that there is, as we saw, there is huge GHG mitigation potential with demand side interventions alone. And what we need is a framework or research agenda to better understand the factors that enable sustainable energy behaviors by various actors and support the required system changes and policies. And platforms like Safari can be useful as a decision support system to understand and evaluate cross-sectoral impacts of sectoral interventions and policy choices. I also just wanted to mention that Safari is just a what-if model, like what Professor Angan Banerjee was saying. So it can, while it can look at the extremely optimistic scenarios that I presented right now, perhaps by a user like Professor Chandra, you can also evaluate the effect of a pessimistic scenario as well. Thank you.
Thank you. Thank you, Kaveri. And coming to the last presentation, Mr. Ajay Krishna from the Madras School of Economics. He's a gold medalist and currently pursuing his doctoral degree in economics. Krishna's interests include environmental economics, sustainable development, climate change, and transportation. The topic for his presentation is medium-term projections of vehicle ownership, energy demand, and vehicular emissions in India. So Krishna, over to you. And along with your presentation, we are past time. We've missed our tea break as well. So it's up to you to get us a cup of tea. All the presentations have been so interesting that I've not been able to stop people in time. But I think it's worth getting the knowledge.
Good evening, everyone. Good evening, and thank you, Chair, for inviting me to speak. And I would also like to thank TIFAC-IIASA for giving me this opportunity to present my work amongst such beautiful minds today. And I believe, as the Chair said, I'm the last speaker, so I'll try to keep it very short and probably be a pastime as well. As ma'am said, I'm a PhD scholar at Madras School of Economics, currently in my third year. And this presentation happens to be one of my working paper, which is currently published in MSc Working Paper Series. I will leave the links at the end of the presentation. I hope the presentation is accessible to the audience. It's an open access free article as well, which you can download from SSRN. It's a preprint version, so it will be helpful. I'll be happy to hear back any comments and suggestions on this as well. So just to set a brief overview, India happens to hold one of the largest vehicle populations in the world, roughly third according to WHO's data set. And if I have to continue the data set to the recent numbers, probably we are on par with United States of America in terms of total number of vehicles registered in the country. And of late, since the last decade or so, this growth of vehicle population in India has roughly doubled in size. And which also is this exponential rise is also very skewed in terms of private vehicles. As we can see in the graph to the top right, in 1960, 6 out of every 10 vehicles on roads were privately owned, which has now crept up to 9 out of every 10 vehicles on roads are actually owned by private owned vehicles. And the literature does give out a few reasons as to why this happens. Rising population, economic growth, rising per capita income, your disposable income rises, people have aspirations of a better life, increased standard of living, comfort in terms of mobility, and India does check all these boxes. And we are not yet at the peak. We still have a long way to go, and which directly transfers into a scenario where we are left with too many vehicles on roads and too much of congestion happening. So what this work predominantly does is it tries to project the medium-term projections of vehicle ownership, vehicle stock, and also tries to estimate energy demands and also give out emission scenarios, what would happen. So I'll just brush through these literatures due to the paucity of time. So what the rationale for this work, actually, after an extensive review of literature, what we found out was a couple of things were actually left out in the literature, which required a detailed analysis. For example, longer time series data. Much of the literature does not use this long time series of data, which was available to us, thankfully. And also the penetration of electric vehicles and the growing presence of them in the current context was not included in much of the studies. And also finding a more efficient framework to approximate on-road vehicles. One of the subsequent slide will talk about this in a bit more detail. And also we wanted to make it a comprehensive analysis. We wanted to make sure that people do realize that EVs are not entirely green. They also consume energy in terms of getting charged, and these comes from grids which are not totally green. So EVs do emit in terms of charging facilities, in terms of charge that we put on the EVs. They are also one of the sources of CO2 emissions. So also in terms of making it more comprehensive, we wanted to include road infrastructure requirement, how much of road infrastructure will be required, and also constructing these road infrastructures and maintaining them also emit CO2 emissions. We wanted to capture that as well in terms of this work. So I'll just brush through these methodologies. These are very standard methodologies which are used in literatures of this domain. We do realize that the vehicle ownership and economic variable does not follow a linear relationship. We need to model it using non-linear functional forms. There are a couple of functional forms: logistic, quasi-logistics, and Gompart's functions. The literatures are very standard in terms of using Gompart's functional form. Tagore et al., in fact, in 1999, one of their papers published that they have tested all the functional forms and demonstrated that Gompart's functional form fits the historical data better in terms of mapping the curvature, which actually there are two curvatures. One is the takeoff zone, one is the saturation zone. And India has actually gone past the takeoff zone, and we are exponentially rising. And the point of this entire paper is to make sure that the saturation happens way early than what European countries and US have had. Moving on, we move to the approximation of on-road vehicles. This is one part which actually differs from most of the literatures. So most of the literature, what they do is to approximate the number of vehicles on road. They tend to use this rule of thumb, which is take 2/3 of vehicles registered as the vehicles moving on road, which we clearly explicitly show that this will lead to this has limitations in terms of underestimating and overestimating the on-road vehicles, which is talked about in a bit more detail in the working paper. And from there on, we move to, these are the functions and equations. I don't want to bore you with the equations, which are used to estimate fuel demand as well as local and global pollutant emissions for both internal combustion engine vehicles and also electric vehicles. This probably will give you a better idea as to what this work has done. The boxes are exercises, and the arrows actually shows the process which is used or variables which are used to get to the start or end points. So first we start with projecting vehicle ownership. We then move on to estimating total vehicle stock, and then approximate the number of vehicles on road. And from there on, we figure out the total kilometers traveled, and we then use the emission factors to figure out the pollutant emissions. And also we use battery capacity and battery range and also fuel efficiency to figure out total energy and fuel demand. So data and sources, I'll just skip past those. These are the assumptions, fairly standard assumptions in terms of literatures of this domain. And these are the results. So what stands out here is, so the variables of interest are statistically significant, even at 1% level of significance. And also we do see the S-shaped curve. I'm not sure if it is visible. I can just zoom in a bit. Yeah, these are the S-shaped curve for both two-wheelers and cars. And the orange ones are the actual lines, and the yellow ones are the projected values given the saturation level that we have used. These are very conservative saturation levels that we have kept, keeping in our minds that Indian roads are already cramped. Okay, this has gone somewhere else. Sorry.
come to the results.
Yeah, so moving on to the results for two-wheelers and four-wheelers, we do see the S-shaped curve. We also see the two-wheelers will be saturated. We will achieve the saturation for two-wheelers roughly around mid-2030s under the aggressive scenario, and also for four-wheelers, we will achieve saturation roughly latest by 2050 under the aggressive scenario, and under conservative scenario, this might keep prolonging till 2060. Again, roughly at the peak, we might have 200 to 250 million vehicles plying on roads, which aggregate to 1.6 to 1.9 trillion kilometers of annual vehicle kilometer traveled. Again, we comparison with results. We try to validate our results for the subsequent years. We had the data till 2019, 2020. We validated using the Vahan dashboard for 2020 and 2021. Our results happens to be falling in the range of the Vahan's actual numbers. Coming on to fuel demand, we have projected fuel demand for two different cases, one with no EV adoption, another with EV adoption. In both the cases, what do we see is the proportion of fuel demanded by four-wheelers starts to increase from 52% in 2020, it creeps up to 60% in 2030. Again, these are for EV adoption scenarios. In this, we present only the energy demand from EVs and also fuel demand saved in terms of adopting for EVs. Again, moving on, again, for emission scenarios, we have two different cases, one with EV and one without EV. In both the cases, we see the emissions to drop off. These are fairly due to achieving saturation of two-wheelers and fuel and emission efficiency improvements, which are happening, and adoption of electric vehicles, and also improvement in grid emission factors. So on the left, on the graph on the left, on CO2 emissions is rising, and on the right-hand side, you can see it drops down. This drops down predominantly due to the low saturation level, and also emission and fuel efficiency improvements, and also with adoption of EVs. So these are given for both status quo situations, which is business as usual, and also for the most improved situations. Moving on to the final part, this is regarding road infrastructure. To accommodate the existing road density, we might need roughly 38 to 40 lakh kilometers of road to be built in the next coming 16 years, which in total might add up to 3 billion tons of CO2 emission just in terms of road constructions, and 400 million tons of CO2 emission in terms of maintenance of these roads. In conclusion, what we see is two-wheelers tend to achieve saturation before four-wheelers. The enormity of fuel demand and emissions will have a significant impact in our net zero push. So we need to bring in a role of appropriate transport policy measures are extremely necessary in terms of achieving this very conservative saturation levels that we have got. This level of saturation level will take us back to 2018 levels of emissions by 2030 to 2040, roughly between 2030 to 2040, and we can probably decongest our Indian roads. Policy measures, I have detailed out this in my working paper. People can have a look at it. These are fairly at an aggregate level, so the policies cannot be homogeneous for all entire India per se. We are currently doing a city level work on which we have policy prescriptions specific to each cities. One predominant policy measure that we would like to see would be inclusion of comprehensive mobility plans in all the city development policies and all smart city documents which each city go through. Probably including comprehensive mobility plan could be a better way forward, so that better transport modeling can be done.
Sure.
Going ahead, opportunities, we are looking to include all other road vehicles, which could include buses, trucks, and autos, and all these. And thank you for sharing your valuable time, and advance happy Independence Day wishes to everyone. Thank you. And these are the links to my working paper. You can have a look.
Thank you. Thank you, Mr. Krishna. So with that, I think let's give all our speakers a hand again and end this session. Thank you, everyone. And I guess we'll just have to whiz to the next panel discussion. We're already late for that.
Yes, ma'am, but before we part, I think I'll request you to please felicitate our speakers. I would once again like to thank each one of you present virtually and here in present. On behalf of TIFAC-IIASA, for your gracious presence here. To Dr. Kaveri. Dr. Rohit, thank you, sir. Thank you for being with us. Mr. Ajay Krishna. Thank you, Ajay, for being with us. After this, we'll move to the auditorium 1 for the final panel discussion to end this event. Thank you, everyone. Thank you, Chair. Thank you, speakers.